We often hear the astonishing idea that the observable universe, the portion of the cosmos we can study and detect, is just a small fragment of the whole. In fact, it's estimated that only about 5% of everything that exists is visible to us. The rest of the universe, an overwhelming majority, is veiled in the shadows of dark matter and dark energy, two phenomena that have long bewildered scientists and captivated the imaginations of curious minds. These cosmic mysteries are not merely abstract ideas. They fuel an ongoing global quest to understand the fundamental nature of reality. This pursuit of knowledge is riddled with oddities, strange signals from deep space, inexplicable celestial phenomena, and enigmatic cosmic events that challenge our most basic assumptions. As researchers continue to probe the depths of the universe, they encounter one mind-boggling discovery after another, forcing them to rethink everything they thought they knew about the fabric of the cosmos. Among the most perplexing of these are dark matter and dark energy, which remain some of the greatest challenges to modern science. Dark matter, for example, makes up roughly 27% of the universe, but it remains utterly invisible. It neither emits, reflects, nor absorbs light, rendering it undetectable by traditional means. Its presence is only inferred by its gravitational influence on visible matter. One compelling example of this is found in the way galaxies move. Galaxies spin so rapidly that, based on the visible mass alone, they should be flying apart. Yet they remain intact, leading scientists to conclude that an unseen, invisible mass, dark matter, is exerting enough gravitational force to hold them together. But dark matter is only half of the equation. The even more baffling phenomenon of dark energy is thought to account for a staggering 73% of the universe. This mysterious force is believed to be responsible for the accelerating expansion of the cosmos. Observations show galaxies moving away from one another at an ever-increasing pace, defying expectations based solely on gravitational forces. The presence of this accelerated expansion points to an unknown force that is driving galaxies apart. While some hypotheses suggest that dark energy might be related to the inherent energy of space itself, its true nature remains elusive. Despite our best efforts, the puzzle of dark energy continues to frustrate and intrigue scientists. Then there are the fast radio bursts, FRBs, an astronomical phenomenon that has captured widespread attention in recent years. These are incredibly brief but intense bursts of radio waves originating from distant galaxies. They last only milliseconds, but in that fleeting moment, they release an enormous amount of energy. The origin of these bursts remains a mystery, with explanations ranging from catastrophic events such as the collision of neutron stars to more exotic ideas like signals from advanced extraterrestrial civilizations. Each new FRB detected raises more questions than answers, making it one of the most exciting and active areas of research in modern astronomy. Another captivating mystery is the so-called WOW signal, which was detected in 1977 by the Big Ear radio telescope. This one-time radio signal appeared to come from the direction of the Sagittarius constellation, and despite numerous attempts to detect a similar signal, none has been found. This raises profound questions. Was the WOW signal a product of a natural cosmic event, or could it have been a communication from an intelligent civilization elsewhere in the universe? The investigation into such phenomena exemplifies humanity's ongoing search for answers about our place in the universe. As we look deeper into the universe, we also find galaxies that defy conventional expectations. One such type is the starburst galaxy. Unlike typical galaxies, which form stars at a steady pace, starburst galaxies experience periods of intense star formation, often producing new stars at a rate several times higher than that of our Milky Way. This rapid formation is often triggered by interactions with neighboring galaxies or other cosmic influences, leading to a surge in gas and dust that fuels the birth of new stars. These galaxies are not just fascinating in their behavior, but may also provide important clues about the processes that drive galactic evolution. Another curious class of galaxies are the green peas, named for the striking greenish hue they emit, a result of the intense oxygen and other elements released during star formation. These compact, relatively small galaxies challenge traditional notions of size and mass in the study of galactic evolution. Despite their small scale, they are highly efficient at producing stars. Their unique properties raise critical questions about the conditions necessary for star formation and the life cycle of galaxies. Studying these unusual galaxies offers a valuable opportunity to explore the complex dynamics of galaxy formation and the broader mechanisms that shape the universe. The implications of these discoveries extend far beyond simple academic curiosity. By delving into the unusual behaviors of galaxies, scientists are able to refine our understanding of how galaxies like our own came into being. They are learning how galaxies grow and evolve, how they interact with one another, and how mergers and other cosmic events can influence their development. These studies may also suggest that what we consider normal in the universe may only represent a snapshot of a much larger and more dynamic cosmic process. Similarly, planets that defy our existing models often force astronomers to reassess the fundamental principles governing planetary formation. One of the most notable examples of this is the discovery of hot Jupiters, gas giants that orbit close to their parent stars, much closer than traditionally believed possible. For years, scientists thought that gas giants required a significant distance from their stars to accumulate the massive amounts of gas needed for their formation. Yet, the existence of these hot Jupiters forces us to reconsider the mechanisms behind planetary formation. How did these massive planets manage to form in such inhospitable environments, and what does this mean for our understanding of the processes that give rise to planets? The universe is an unfathomably complex place, and with each new discovery, we peel back another layer of its mysteries. From the invisible forces of dark matter and dark energy to the strange behaviors of galaxies and the unexpected formation of planets, science continues to encounter puzzles that challenge our deepest assumptions. The more we learn, the more we realize how little we truly understand, but that only fuels the excitement and wonder of the scientific journey. As we continue to explore the cosmos, we are reminded of how vast, mysterious, and awe-inspiring the universe truly is. The discovery of planets with unusual compositions has introduced an intriguing paradox that challenges our existing frameworks of planetary science. These planets, often too large to be classified as terrestrial yet significantly smaller than gas giants, defy the conventional categories we once relied on. Many of these exoplanets are composed of materials that do not fit neatly into any established models of planetary formation, forcing researchers to reconsider and propose entirely new models. One such model explores the concept of planetesimals, the small, rocky bodies that coalesce during the early stages of planet formation. In different environmental conditions, these planetesimals may interact in ways that lead to the creation of planets whose characteristics are radically different from those observed in our own solar system. This shift in perspective highlights the adaptability and dynamism of modern scientific inquiry. As our technological capabilities have advanced, allowing us to discover a broader range of exoplanets in various sizes and compositions, we find ourselves encountering planetary phenomena that do not align with the behaviors and patterns we see in our own solar system. Planets exhibiting extreme atmospheric conditions, unusual weather patterns, or unfamiliar chemical compositions compel scientists to ask new questions about the processes that shape a planet's evolution. Stellar radiation, gravitational influences from nearby stars or planets, and chemical interactions within a planet's atmosphere must all be considered when attempting to explain these anomalies. These extraordinary discoveries not only deepen our understanding of the universe, but also serve as a reminder that scientific models are never static. They are constantly evolving as new data challenges our assumptions. The field of planetary science is marked by its willingness to embrace uncertainty and adapt in the face of the unknown. The search for answers to these planetary anomalies pushes the boundaries of what we know and sparks innovative theories that expand our understanding of how planets form, how they function, and how they can be so diverse in their characteristics. The quest to understand the cosmos does not end with planets, however. Among the universe's most perplexing and enigmatic objects are black holes, quasars, and dark matter. Each of these phenomena raises fundamental questions about the very nature of space and time. Black holes, Regions of space where gravity is so intense that nothing, no matter, no light, can escape have captivated the imagination of scientists and the public alike since their theoretical prediction by Albert Einstein's theory of general relativity. These cosmic giants come in various sizes, from stellar black holes formed by the collapse of massive stars to the supermassive black holes found at the centers of galaxies. Despite decades of research, the origins and evolution of black holes remain largely mysterious, as the processes that lead to their formation are not yet fully understood. Particularly perplexing is the question of how supermassive black holes first formed and grew to their immense sizes. These objects, which can be millions to billions of times more massive than our Sun, appear to have existed since the early universe. Theories abound, but the precise mechanisms of their formation and the way they accumulate mass over time remain elusive. Researchers are still grappling with how these behemoths can influence their surrounding galaxies, often serving as both destroyers and creators of cosmic structures. Then there are quasars, quasi-stellar objects that represent another unsolved astrophysical mystery. These incredibly bright sources of energy are powered by supermassive black holes at the centers of distant galaxies. So energetic are they that they can outshine entire galaxies, emitting far more light than all the stars in a galaxy combined. The very existence of quasars challenges our understanding of the early universe. They are believed to have played a crucial role during the cosmic dawn, a period when the universe was just a few billion years old, but the details of how they evolved remain elusive. The role of quasars in galaxy formation, their influence on surrounding matter, and how they evolve over time are subjects of intense research. One of the most profound mysteries of modern cosmology is the nature of dark matter. Thought to constitute around 27% of the universe's total mass, dark matter remains invisible to our current observational techniques. Unlike ordinary matter, which emits, absorbs, or reflects light, dark matter interacts with the visible universe only through its gravitational effects. Despite its significant contribution to the mass of galaxies and other cosmic structures, we have never directly detected dark matter, leading to a series of hypotheses about what it could be. Some suggest it consists of exotic particles or even unknown forms of matter that do not behave in ways we currently understand. Others propose that dark matter may be a product of unknown forces or quantum effects. However, until it is detected directly, dark matter remains one of the greatest puzzles in science. Together with dark energy, which is thought to be responsible for the accelerated expansion of the universe, dark matter challenges our very conception of reality. The fact that we can observe galaxies, stars, and planets, yet remain largely blind to the majority of the universe's mass, forces scientists to rethink their understanding of cosmology. The universe, it seems, is far more complex and mysterious than we could have ever imagined. Yet, it is in this complexity that the true beauty of science lies. The ability to continually refine our models, adjust our understanding, and push forward into the unknown. As we develop new technologies and methodologies, it is possible that one day we will unlock the secrets of dark matter, black holes, and quasars. The mysteries that once seemed insurmountable may eventually reveal themselves, reshaping our understanding of the universe and our place within it. Until then, the search continues, an ongoing journey of discovery that brings us closer to the heart of the cosmos, where answers to some of the most profound questions of existence await. However, its presence can only be inferred by examining the gravitational effects it exerts on visible matter. For example, galaxies spin at such incredible speeds that, by all expectations, they should fly apart. If only the visible matter were present, such as stars and gas, these galaxies should not remain intact. Instead, they hold together, defying conventional physics. The reason for this phenomenon? An unseen mass. This discovery of dark matter raises profound and far-reaching questions about the very nature of the universe. It forces us to confront a staggering truth. A significant portion of the cosmos remains utterly undetectable through traditional observational methods. The intrigue does not end there. Enter dark energy, a mysterious force that makes up about 73% of the universe. This unseen entity acts as a kind of anti-gravity, pushing the universe to expand at an accelerating rate. Discovered only in the late 20th century, dark energy has rewritten our understanding of the cosmos, presenting scientists with an entirely new paradigm. If the expansion continues unchecked, the universe may eventually evolve into an immense cold and dark void. The presence of dark energy complicates not only our models of cosmic evolution, but also our philosophical conceptions about the universe's eventual fate. The interplay between dark matter and dark energy challenges our most fundamental principles of physics. The more we explore these enigmatic forces, the more we realize how little we truly understand about the universe. Observations combined with theoretical physics create a dynamic field of inquiry, urging us to question the very fabric of reality itself. As we delve deeper into these cosmic puzzles, we inch closer to unlocking the universe's deepest secrets. Yet the vast majority of the universe remains a profound enigma, its true nature slipping through our grasp like the faintest shadow. The concept of missing matter in the universe has captivated scientists for decades. For much of that time, astronomers have recognized that visible matter, the stars, planets, and galaxies we can see with telescopes, comprises only a tiny fraction of the mass required to account for the universe's gravitational effects. What then is the rest of the matter? The answer lies in the mysterious entity known as dark matter, which has remained invisible to our instruments, leaving scientists to speculate about what it truly consists of. One groundbreaking revelation comes from studies of galaxy clusters. Using synchronized radio arrays and other advanced technologies, astronomers have uncovered vast clouds of cool gas that existed in the early universe. This gas represents a significant portion of the universe's baryonic or normal matter, yet it has eluded detection by conventional means. Its existence suggests a deeper truth. The normal matter we observe is not the entirety of what exists. These findings point to the likelihood of other, yet undiscovered forms of matter lying hidden in the cosmic shadows, far beyond the reach of our current instruments. Further complicating this mystery is the innovative technique of gravitational lensing. By observing how light bends as it passes around massive objects, scientists can detect the presence of unseen mass. This method has provided crucial insights into how matter is distributed across galaxies, suggesting that the missing matter is not merely absent, but rather exists in a more complex and intricate form than previously imagined. These lensing observations hint at structures and forces within the universe that are still largely unknown. Additionally, the study of the cosmic microwave background, CMB, the faint remnants of radiation from the Big Bang, has proven to be a critical tool in understanding the universe's composition. By measuring fluctuations in this background radiation, researchers have deduced that the total mass energy content of the universe is far greater than what can be directly observed. This finding lends further support to the notion that the universe is teeming with forms of matter that have yet to be fully understood, suggesting that new physics lies in wait, just beyond the horizon. As scientists continue to probe these mysteries, their quest to uncover the universe's true composition remains unrelenting. Every new discovery seems to deepen the questions rather than provide answers. Yet each piece of evidence brings us one step closer to filling in the vast gaps in our understanding. The pursuit of knowledge about the universe's elusive ingredients, dark matter, dark energy, and beyond, is an ongoing journey, one that has the potential to reshape our very conception of reality. In this search for answers, the exploration of extreme environments in space offers a unique and valuable perspective. These environments, such as the icy moons of Jupiter or the blazing surface of Venus, present conditions that push the boundaries of everything we know about physics, chemistry, and even biology. The way matter behaves under extreme temperatures, pressures, or radiation could provide us with clues about phenomena that remain beyond our grasp. Take Europa, one of Jupiter's moons, for example. Beneath its frozen crust lies a vast ocean of liquid water, which could potentially harbor the conditions necessary for life. The study of such environments does more than just fuel the search for extraterrestrial life. It also provides essential insights into the behavior of dark matter and dark energy. These forces, which have been shown to influence galaxies and the expansion of the universe, might also be at play in these extreme environments. offering an intriguing connection between the behavior of matter under harsh conditions and the deeper structure of the cosmos itself. Furthermore, scientists have been investigating the radiation belts of Saturn, intense regions where high-energy particles are trapped by the planet's magnetic field. Observations of the effects of this radiation on spacecraft, both robotic and human-made, have led to an increased understanding of radiation's role in space. These studies are instrumental in uncovering the nature of cosmic rays, their origins, and their impact on our understanding of space phenomena. Thus, the exploration of these extreme environments serves not only as a means of understanding the most extreme conditions in the universe, but also as a crucial link to some of its greatest mysteries. Through this lens, the mysteries of dark matter, dark energy, and the fundamental forces of the cosmos become a little less elusive. While there is still much to uncover, the search for answers continues, driven by the promise that each discovery may eventually illuminate the vast darkness of the universe's most hidden secrets. In the vast and unexplored realms of our universe, every mission to distant celestial bodies, especially gas giants, provides invaluable insights that unravel the complexities of cosmic evolution. These gas giants, with their dense atmospheres and extreme conditions, serve as natural laboratories for studying the intricate chemical processes that occur under immense pressure. Their atmospheres reveal how substances interact and transform under duress, providing clues about the formation and behavior of distant, complex structures across the cosmos. By analyzing these planetary systems, we begin to piece together a larger narrative, one that encompasses the evolution of galaxies, the acceleration of the universe's expansion, and the overall dynamics of cosmic evolution. Each expedition into these extreme environments is not merely an exploration, but a crucial step toward deciphering the cosmic anomalies that continue to puzzle astronomers and physicists alike. Questions such as the uneven distribution of galaxies, or the mysterious acceleration of the universe's expansion point, to the existence of forces and phenomena yet to be fully understood. By studying the most hostile conditions found in space, we not only gain a deeper understanding of our own solar system, but also uncover fundamental processes that govern the very fabric of the universe. This ongoing exploration helps us navigate both the visible and the invisible aspects of reality, weaving a richer, more complete understanding of the cosmos. At the forefront of this scientific journey are theoretical physicists who serve as the architects of our understanding of the universe. They probe the unknown, constantly seeking to develop frameworks that can explain the fundamental behaviors and laws governing natural phenomena. The work of these physicists often begins with the observation of unexplained or puzzling behaviors within the cosmos, such as the unusual composition of dark matter or the strange acceleration of distant galaxies. From these mysterious observations, they formulate hypotheses and craft mathematical models, offering potential explanations for these cosmic enigmas. In essence, they transform abstract ideas into structured theories that can be rigorously tested and explored. One of the most powerful tools at the disposal of theoretical physicists is mathematical modeling. This technique allows them to simulate complex conditions and predict outcomes based on their theories, even for environments far beyond our reach. For instance, these models can predict the behavior of particles at incredibly high energies, conditions that don't naturally occur on Earth. However, they can be studied indirectly through experiments like those conducted at particle accelerators. These mathematical frameworks not only guide experiments, but also provide a roadmap for researchers, directing them toward new avenues of discovery. In doing so, they bridge the gap between theory and empirical data, fostering a continuous cycle of understanding. Moreover, theoretical physicists are often engaged in the ambitious pursuit of unifying various branches of physics. By seeking a comprehensive understanding of the fundamental forces that shape the universe, they strive to create a single, coherent framework. String theory is a prominent example of this effort. It proposes that rather than being simple point-like particles, the basic building blocks of matter are actually tiny, vibrating strings. In fact, this bold theory aims to reconcile the two pillars of modern physics, quantum mechanics and general relativity, by addressing some of the contradictions and anomalies that arise at cosmic scales. Through such efforts, theoretical physicists provide a broader context, one that may eventually hold the key to understanding the universe's most perplexing phenomena. As these scientists push the boundaries of knowledge, they frequently collaborate with experimental physicists who gather empirical data to either validate or challenge the theoretical predictions. This ongoing dialogue between theory and experimentation is a vital aspect of the scientific process. It drives the advancement of our understanding of the universe, ensuring that our models evolve in response to new discoveries and insights. Far from being mere obstacles, the mysteries of the cosmos are seen as invitations for deeper exploration, urging humanity to stretch the limits of knowledge and curiosity. Yet, not all cosmic phenomena align seamlessly with our current understanding of physical laws. This discord often arises from the inherent complexity of the universe itself. The laws of physics, as we understand them, work remarkably well under the conditions we can observe and experiment with on Earth. However, in the extreme environments found in the far reaches of space, these same laws can produce unexpected results or appear inadequate. For example, black holes remain one of the most significant puzzles in physics. According to general relativity, nothing, no matter, no light, can escape a black hole's gravitational grip. Yet the discovery of phenomena such as Hawking radiation suggests that black holes might emit radiation and, over incredibly long timescales, could even evaporate. This groundbreaking insight forces scientists to reconcile the principles of quantum mechanics with general relativity, pushing the boundaries of existing theoretical models and suggesting that our current understanding may be incomplete. Similarly, the acceleration of the universe's expansion, an observation made possible through the study of distant supernovae, points to the mysterious presence of dark energy, a force that makes up around 70% of the universe's total energy content. While dark energy fits neatly within our observed data, it stands in stark contrast to our traditional understanding of gravity and dynamics. This discrepancy invites scientists to rethink the very fabric of cosmic understanding. Dark energy, along with other unexplained phenomena such as gamma-ray bursts and the peculiar behavior of pulsars, highlights the limitations of our existing models. These anomalies serve as a constant reminder that science is a living, breathing field, one that is always evolving as new data and technologies become available. As we continue to gather data and refine our technological tools, we may eventually uncover truths that challenge and expand upon our current scientific models. The discoveries of phenomena that elude our understanding not only spark intellectual curiosity, but also push the scientific community to revise or even revolutionize the fundamental concepts of physics. Take, for instance, the unexpected behaviors of dark matter and dark energy. For decades, these enigmatic components have shaped our view of cosmic structure and expansion. Yet, new observations might reveal phenomena that our current theories cannot fully explain. This could force researchers to reconsider the very nature of gravity itself, or to explore entirely new forces at play within the cosmos. Such revelations often lead to an exciting and expansive avenue of research, one that invites collaboration across disciplines between physicists, astronomers, and mathematicians. By coming together, these scientists forge new theories that account for the strange and inexplicable phenomena that challenge our existing paradigms. As our understanding of the universe grows, so too does the realization that we are only scratching the surface of a far deeper, more intricate reality, one that continues to unfold before our eyes, inviting us to push the boundaries of human knowledge ever further. Such discoveries, when made, tend to trigger cascading effects that echo far beyond their immediate implications. They ripple through the landscape of technology and practical applications, pushing the very limits of our technological capabilities. The challenges posed by cosmic phenomena constantly push us to innovate, not just in our understanding of the universe, but also in the tools we use to study it. As we strive to make sense of the anomalies that emerge from deep space, these discoveries have a remarkable way of driving advancements in seemingly unrelated fields, creating a feedback loop that fuels progress. For instance, the study of gravitational waves, those subtle ripples in space-time, has led to the development of cutting-edge technologies and methods that extend far beyond astrophysics. Techniques born out of the need to observe these faint signals have found application in diverse areas, ranging from medical imaging technologies to advancements in telecommunications. In this way, what might initially seem like an abstract scientific inquiry can inspire tangible innovations that benefit the everyday lives of people. Beyond the technological advancements, the implications of these discoveries are deeply philosophical. The encounter with cosmic phenomena that defy our current understanding challenges us to reconsider our place in the universe. It forces us to confront the very limits of human knowledge, reminding us that the universe is far more complex and mysterious than we can imagine. At the same time, it fuels a sense of awe and wonder, a spark of curiosity that drives the human spirit to explore and push further. The quest to understand the universe is not a finite goal. It is an endless journey, one that mirrors humanity's own enduring search for meaning. Each new anomaly uncovered whispers to us that there is always more to discover, more mysteries to solve, and more questions to ask. With every new discovery, we come a step closer to answering the most fundamental question of all: what is the nature of reality? One of the most captivating theoretical constructs in astrophysics is the concept of wormholes. These hypothetical tunnels in space-time, often described as shortcuts through the fabric of the universe, have fascinated both scientists and science fiction enthusiasts for decades. To visualize a wormhole, imagine the universe as a vast, two-dimensional sheet of paper. If you were to fold this sheet so that two distant points on its surface meet, you could imagine how a wormhole might work, connecting two distant regions of space almost instantaneously. This idea stems from Einstein's theory of general relativity, which suggests that mass and energy can warp space-time itself. While general relativity allows for the possibility of such wormholes, convincing proof of their existence has yet to be discovered. To date, wormholes remain firmly within the realm of speculation, a fascinating but unproven idea. Scientists theorize that if wormholes exist, they might be stabilized by a form of exotic matter, a substance with negative energy density that has yet to be conclusively detected. This exotic matter would be crucial in preventing the wormhole from collapsing under its own gravitational forces before anything could travel through it. In the context of space travel, the potential of wormholes is tantalizing. If we could find a way to manipulate them, the vast distances between stars, distances that would normally take thousands of years to traverse, could be reduced to mere moments. This opens up an entirely new realm of possibilities for interstellar exploration, communication, and even our understanding of time itself. However, despite their theoretical allure, wormholes remain speculative. Physicists continue to explore the fundamental laws of the universe in an effort to determine whether wormholes could exist in reality, and if so, whether we could ever manipulate them for practical use. This ongoing research reflects the ever-evolving nature of our understanding of the cosmos, showing that even as our knowledge of physics advances, some ideas, like wormholes, still straddle the line between science fiction and science fact. In parallel to the study of wormholes, multidimensional theories, particularly those arising from the realm of string theory, have captivated the minds of scientists seeking to unravel the mysteries of the universe. These theories propose that our familiar 3 dimensions of space and 1 dimension of time might be just a small part of a much larger, more complex reality. In some versions of these theories, as many as 10 or 11 dimensions are suggested, each of which could offer new insights into long-standing mysteries in physics. One of the most perplexing of these mysteries is the nature of dark matter and dark energy. Together, these entities make up about 95% of the universe's total mass energy content, yet they remain largely invisible and undetectable by current instruments. Multi-dimensional theories offer new frameworks in which dark matter and dark energy might behave differently than what we currently understand. They suggest that these mysterious forces could be interacting in higher dimensions, perhaps influencing the cosmos in ways that we cannot perceive in our limited 4-dimensional perspective. What we interpret as the shadow of these interactions might, in fact, be just a small fraction of a far more intricate and profound reality. Despite the theoretical potential, these multi-dimensional models face significant hurdles. One of the primary challenges is the energy scale at which these extra dimensions might become apparent. Current technology, such as the Large Hadron Collider, can only probe energy levels that are far below those required to test the existence of additional dimensions. Without experimental evidence to support or challenge these theories, they remain largely mathematical constructs, intricate, elegant, and compelling, but still without empirical proof. Beyond the technical challenges, there are also conceptual hurdles to overcome. Our understanding of the universe is deeply rooted in the 4 dimensions we experience daily. Introducing additional dimensions that might be too small, too vast, or too abstract for us to intuitively grasp, can lead to results that are difficult to visualize or rationalize. These theoretical frameworks, though mathematically consistent, often stretch the limits of human imagination and understanding. Ultimately, these multidimensional theories challenge us to think beyond the boundaries of our own perceptions. They invite us to consider that the universe might be far stranger and more complex than we ever dared imagine, offering new avenues of inquiry that could one day reshape our understanding of everything, from the smallest particles to the largest structures in the cosmos. And in that search, just as with the study of wormholes and other cosmic anomalies, we are reminded that the journey to uncover the secrets of the universe is as vast and mysterious as the universe itself. Moreover, the intricate mathematics behind formulating these theories can often appear overwhelming, creating a barrier to communication and making it difficult to share these profound ideas with a wider audience. This challenge becomes particularly pronounced when we aim to foster a deeper public understanding of the complex theories that shape our view of the cosmos. Despite these hurdles, the exploration of multidimensional theories stands as a testament to humanity's unyielding drive to uncover the unknown. Scientists persistently probe the deepest corners of the universe, striving for a more unified theory that can explain the vast interconnected nature of all things. Consider, for example, the idea of the multiverse, a concept that has profoundly altered the way we think about our existence in the grand scheme of reality. This theory posits that our universe might not be the singular entity we once believed, but rather one of many universes, each with its own unique properties, physical laws, and histories. Such a notion forces us to confront the limits of our understanding and fundamentally challenges our perception of what makes our universe exceptional. If there are countless other universes out there, universes that may follow different rules and give rise to entirely distinct forms of reality, then the significance we once placed on our own universe starts to fade. We must shift our focus from seeing our universe as a solitary, unparalleled entity to considering it as just one part of a much larger ensemble of realities. One particularly fascinating aspect of multiverse theories is the sheer breadth of possibilities they introduce. Imagine a universe where the fundamental constants of nature are not quite the same as in our own. Perhaps these differences could allow forms of life and phenomena that we cannot even begin to imagine. This vision stretches the boundaries of our imagination, proposing a nearly infinite range of outcomes, each representing different answers to the same fundamental questions that we seek to answer in our own universe. Such a concept shifts the spotlight away from Earth as the one and only cradle of life, encouraging us to rethink our place in the cosmos. Every universe in this scenario might embody a different potential outcome of the universe's fundamental laws, creating a breathtakingly vast multiverse of infinite realities. Beyond their impact on our conception of existence, multiverse theories also force us to reconsider the very nature of scientific inquiry. Traditionally, scientists have worked under the assumption that the universe they observe is unique, that our laws of physics, our constants, and our history are unlike any other. However, if we are to accept the possibility that multiple universes exist, each with its own laws of physics and unique conditions, it suggests that our understanding may be limited to a mere sliver of a far grander whole. We are confronted with the humbling idea that our observations might be just a small piece of a much broader and deeper puzzle, one that we have barely begun to comprehend. This realization emphasizes the notion that scientific exploration is inherently constrained by the particular laws and conditions present in our own universe. We can only observe the universe as it is, through the lens of the physical laws that govern our reality. If multiple universes are indeed out there, each with different physical rules, then our current framework of understanding might only be scratching the surface. The deeper we dive into these theories, the more we begin to grasp how limited our knowledge truly is and how much more there is left to explore. The philosophical implications of multiverse theories are even more profound. They challenge our most basic notions of existence, probability, and the nature of reality itself. If multiple universes exist with varying laws of physics and completely different forms of life and existence, what does it mean to be unique? What does it mean to exist at all? As we wrestle with these questions, we begin to appreciate the complexity and interconnectedness of reality on a cosmic scale. Multiverse theories invite us to venture beyond the confines of our current understanding, to think beyond the observable, and to reconsider our place in the larger fabric of existence. In exploring these ideas, we are not merely challenging scientific concepts. We are also questioning the very essence of what it means to be part of the universe. Our journey into the multiverse is as much a philosophical quest as it is a scientific one. It forces us to confront the idea that our understanding of reality, and by extension, our place in the cosmos, might not be as fixed as we once thought. The more we ponder these possibilities, the more we begin to realize that the search for knowledge is a never-ending journey, one that stretches across infinite dimensions, with each discovery opening new doors to deeper understanding. As we delve deeper into our understanding of the universe, we are also confronted with the tantalizing possibility that there may be undiscovered forces at work, forces beyond the four fundamental ones that currently form the foundation of our understanding of physics. Gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, these are the pillars upon which the current framework of physics stands. Yet, the quest for knowledge often brings more questions than answers, and scientists continue to investigate whether there are additional forces in play that could influence the behavior of the universe in ways we have not yet imagined. One of the most compelling pieces of evidence for the existence of unknown forces comes from the mysterious phenomena of dark matter and dark energy. Observations suggest that visible matter, everything we can observe with telescopes, from stars and galaxies to planets and nebulae, comprises only a small fraction of the total mass and energy in the universe. Dark matter, which does not emit, absorb, or reflect light, exerts a gravitational influence on visible matter, yet its true nature remains one of the greatest mysteries in modern physics. Similarly, dark energy appears to act as a force driving the accelerated expansion of the universe, but like dark matter, its exact properties remain elusive. Both dark matter and dark energy suggest the presence of forces or phenomena beyond the four known forces. Their strange and unexplained behavior hints at something far more complex at play, a layer of reality that remains hidden from our current understanding. As scientists continue to explore these mysteries, they are forced to confront the possibility that our existing framework of physics may not be complete. There may be forces or dimensions beyond the ones we can currently detect, forces that could reshape our understanding of the universe and open up new realms of discovery. Experiments in particle physics have long been a gateway to uncovering the unseen forces of the universe. High-energy collisions, such as those conducted at facilities like the Large Hadron Collider, LHC, present opportunities for groundbreaking discoveries. These collisions, which propel particles to near the speed of light, are not only pushing the boundaries of known physics, but also providing fertile ground for the potential discovery of new particles, interactions, and forces that could radically alter our understanding of the cosmos. The discovery of the Higgs boson, while a monumental milestone, is only the beginning. Even now, as scientists analyze the mountain of data generated by the LHC, they continue searching for anomalies, unexpected behaviors that could deviate from the predictions of the standard model. If such deviations emerge, they may point to phenomena beyond the reach of current theories, sparking a new era in particle physics. Moreover, the search for new forces is not confined to the realm of particle physics. It extends into cosmology. The behavior of galaxies, particularly their rotation, has raised intriguing questions. Observations suggest that the motions of stars within galaxies cannot be fully explained by the gravitational equations currently in use. This implies that there may be a force at play, an unknown entity that we have yet to identify. While the evidence for such a force remains elusive, the continuing advancements in astrophysical research are opening new avenues for discovery. The study of these cosmic irregularities could potentially unveil new dimensions of reality, expanding our understanding of the universe in profound and unexpected ways. In the world of science, distinguishing between scientifically grounded speculation and mere conjecture is crucial. Scientific speculation is not a flight of fancy. It is a process deeply rooted in established methodologies, evidence, and logical reasoning. The act of speculating within a scientific context is much like constructing a bridge built from verifiable observations and existing theories. When a cosmic anomaly is detected, scientists do not leap to conclusions. Instead, they gather data from a multitude of sources. This data, ranging from astronomical observations to experimental results, is meticulously analyzed in search of patterns or irregularities that might point to new phenomena. For example, when gravitational waves were first detected, scientists hypothesized about their origins based on the known laws of physics, refining their theories as more evidence became available. The essence of scientific speculation lies in this iterative process, where each hypothesis is tested and scrutinized in the light of new data. In contrast, conjecture lacks this solid foundation. It may arise from untested assumptions or anecdotal observations that cannot withstand the rigors of scientific inquiry. While conjectures can make for engaging conversation, they rarely lead to productive results. In fields where data is sparse or non-existent, speculation can veer into the realm of fantasy, far removed from the scientific method. The difference between valid speculation and conjecture is not merely a matter of opinion. It is a reflection of how claims are formed and tested. Speculation that is grounded in evidence and rigorous testing drives progress, while conjecture can derail serious inquiry, diverting attention from the pursuit of knowledge. One of the most perplexing mysteries in modern cosmology is the enigma of dark energy. This unknown force is believed to be responsible for the accelerated expansion of the universe, yet its true nature remains a mystery. To explain dark energy, researchers have proposed a variety of theoretical frameworks. One of the leading candidates is the concept of the cosmological constant, a term first introduced by Albert Einstein in his equations of general relativity. According to this theory, the energy density of empty space, or vacuum energy, exerts a negative pressure that accelerates the expansion of the universe. While this theory elegantly fits many of the observed data, it also raises an important question. Why is the cosmological constant so much smaller than what theoretical models would predict? Another possible explanation is the idea of dynamic fields, such as scalar fields, which suggests that dark energy is not a constant force, but one that evolves over time and space. An example of this approach is quintessence, where a scalar field evolves in a manner that accelerates the expansion of the universe. These dynamic models allow for the possibility that the energy density of dark energy could change over cosmic time, opening the door for future observations to distinguish between different theories. Modified gravity theories present yet another avenue of exploration. Some scientists have hypothesized that our current understanding of gravity, as described by general relativity, might require modification on cosmological scales. Models like FR gravity suggest that the force of gravity may behave differently at large scales than it does locally, which could provide an alternative explanation for the phenomena attributed to dark energy. Despite the wide range of theories, a definitive explanation for dark energy remains elusive. The complexity of the concept, combined with the challenges of gathering conclusive observational evidence, means that dark energy continues to be a focal point for research. As new experiments and astronomical surveys provide more data, the hope is that we will eventually find answers to this cosmic riddle. In the coming years, technological advancements are set to revolutionize our understanding of these cosmic anomalies. As we develop more sophisticated instruments, our ability to detect and study enigmatic phenomena will increase exponentially. For instance, future telescopes, equipped with advanced sensors and artificial intelligence, will be able to process vast amounts of data with unprecedented speed. Algorithms will help identify patterns and anomalies far more quickly than humans could ever manage, allowing us to uncover hidden truths in the cosmos. The rise of multi-messenger astronomy will further enhance our capabilities. This approach combines signals from a variety of sources, light from distant galaxies, gravitational waves, and even particles like neutrinos, to create a more complete picture of cosmic events. By correlating these different types of data, scientists will be able to study complex phenomena such as black hole mergers or supernova explosions with greater precision and insight. Another promising development is the advancement of space-based observatories. Unlike their ground-based counterparts, which are limited by the distortion of Earth's atmosphere, space observatories can observe the universe with unparalleled clarity. Instruments like the James Webb Space Telescope are already poised to make groundbreaking discoveries, enabling us to peer deeper into the universe than ever before. These tools will allow us to look further back in time, to the early days of the universe, and study the formation of galaxies and cosmic structures. With each new discovery and technological breakthrough, we are not only expanding our understanding of the universe, we are also reshaping the very framework through which we interpret the cosmos. The future of astrophysics and cosmology holds immense promise, and with it, the potential to unlock some of the greatest mysteries of existence. As advancements in computational power and data analysis techniques continue to evolve, they are poised to revolutionize our understanding of the cosmos in ways previously thought to be out of reach. The sheer ability to simulate complex cosmic events has expanded significantly, allowing scientists to model anomalies and their intricate interactions with unprecedented accuracy. With these tools, researchers are able to test hypotheses and refine theories that explain the underlying physics governing the universe. These technologies, rapidly advancing with each passing year, provide new perspectives, new lenses, through which we can view the vast expanse of space, unlocking secrets that have remained hidden for millennia. One of the most thrilling possibilities emerging from this progress is the potential discovery of wormholes or alternate dimensions. Wormholes, theoretical tunnels through the fabric of space-time, hold the tantalizing promise of shortcuts between distant points in the universe. If these enigmatic structures are real, they could revolutionize space travel. Imagine humanity's ability to travel across galaxies in mere hours or days, instead of relying on the century-long journeys predicted by our current technology. Just picture it, standing on Earth and through a wormhole, stepping directly into a far-off galaxy. This would not just be a monumental leap in technology. It could herald an entirely new era of exploration and discovery, one unparalleled in human history. Simultaneously, the confirmation of alternate dimensions could radically transform our understanding of reality itself. Contemporary physics is based largely on the concept of 3 spatial dimensions and 1 dimension of time, but emerging theories suggest that our universe could contain additional dimensions beyond our sensory perception. Dimensions that could fundamentally alter the way we see everything. If these dimensions exist, they could house not only new forms of matter and energy, but potentially even new kinds of life that lies beyond the scope of our traditional sensory experiences. Such a revelation would undoubtedly expand the very fabric of scientific inquiry, possibly offering new insights into some of the universe's most enduring mysteries, such as dark matter and dark energy. The laws of physics as we know them could shift, inviting new theories and paradigms that we have yet to imagine. Yet, these discoveries wouldn't just impact the realm of science, they would also challenge the philosophical and ethical foundations of human thought. If alternate dimensions are home to parallel universes, then questions about the nature of existence itself would be thrust to the forefront. Could there be other versions of ourselves, living different lives, making different choices? This realization would shake the core of how we think about free will, identity, and our place in the grand scheme of existence. Moreover, these ideas would enrich the realm of science fiction, blending the boundaries between what is possible and what is imagined. As we begin to consider these new dimensions, the stories we tell about humanity's future in the cosmos would evolve, shaping our collective vision of what's possible for civilization. But the implications don't stop there. The technological advancements needed to explore these otherworldly possibilities could lead to breakthroughs across a wide range of fields, including quantum mechanics, general relativity, and even the study of consciousness itself. Understanding how wormholes work, or how alternate dimensions might be accessed, could lead to innovations in communication, computing, and other scientific domains, fundamentally changing how we interact with the universe on a day-to-day basis. Indeed, confirming the existence of wormholes or alternate dimensions would likely propel humanity into an entirely new frontier of exploration and discovery. It would shift our understanding of ourselves and the cosmos from passive observers to active explorers. This would be a transformation on a scale never before seen in human history, as we break free from the limitations of our current understanding and begin to explore the boundless mysteries of the universe in ways we can scarcely imagine. Yet, even within this exciting new frontier, we must also consider how our fundamental grasp of time itself could evolve. In the context of Einstein's theory of general relativity, time is often understood as a linear progression, flowing from the past through the present and into the future. It's a constant, unchanging framework that structures our understanding of reality. However, we also know that time can be influenced by gravity and speed, with the phenomenon of time dilation, showing that the flow of time can speed up or slow down depending on a person's velocity or the gravitational forces at play. As we delve deeper into the mysteries of space and time, these established notions may begin to shift, revealing even more profound insights into the nature of the universe and our place within it. Whether through wormholes, alternate dimensions, or even new understandings of time itself, the future of cosmic exploration promises to unlock secrets that could forever alter the course of human history. The journey into this new frontier has only just begun, and the potential for discovery is limitless. When we dive deeper into concepts like wormholes and the multiverse, the very idea of time transforms into something far more intricate and intriguing. Wormholes, theoretical passages through the fabric of space-time, have long been a subject of scientific speculation. These hypothetical structures could, in theory, bridge vast distances across the universe, providing shortcuts that defy the traditional constraints of space and time. If such passages actually exist, they might allow one to traverse not just space, but time itself. The implications of this are profound. Time, which we typically experience as a constant, unyielding flow from the past to the future, might become malleable. One could potentially revisit the past or glimpse the future, raising complex questions about causality, the relationship between causes and their effects. Such possibilities shatter our conventional understanding of how time operates, suggesting that it could be far less absolute than we once thought. If someone were to travel through a wormhole, could they change the course of history? Could they alter past events, creating paradoxes that ripple through the fabric of reality? The idea challenges our most fundamental assumptions about the universe, pushing the boundaries of what we know about the past, present, and future. On the other hand, the theory of the multiverse introduces an entirely different view of reality. According to this hypothesis, our universe is not the only one in existence. Instead, it is one of potentially an infinite number of universes, each with its own set of physical laws and timelines. In this framework, time may not be a singular, universal experience. Each universe could harbor its own version of time, creating an ever-expanding tapestry of parallel realities. In one universe, an event might unfold differently from how it occurs in another, giving rise to divergent histories and outcomes. The multiverse, thus, presents a picture of existence where time is not uniform, but rather a complex branching structure, with each universe spinning out its own distinct timeline. Exploring these ideas forces us to confront a radical shift in how we perceive time itself. No longer is time merely a linear progression, but a dimension intricately linked to the very fabric of space-time. The geometry of the universe, the nature of wormholes, and the existence of multiple, possibly infinite realities all suggest that time may be far more fluid, interconnected, and complex than we could have ever imagined. Such revelations push us to reconsider not only the nature of time, but also our understanding of existence and the universe as a whole. Speculative theories like these are not just idle musings. They act as powerful catalysts for scientific exploration. By posing ideas that challenge established norms, these theories often inspire new research, driving experimentation and innovation in astrophysics. One such theory, the existence of dark matter, began as a speculative idea to explain the unexplained gravitational effects observed in the cosmos. Since its introduction, dark matter has spurred a multitude of experiments aimed at detecting its elusive presence. Scientists have developed increasingly sophisticated detectors and have begun exploring underground laboratories and even space-based experiments, all in a bid to uncover the true nature of dark matter. Despite its invisibility, dark matter may constitute a significant portion of the universe's total mass, a possibility that continues to drive cutting-edge research. Similarly, the once theoretical concept of black holes has inspired a wealth of experimental and observational work. What was once a purely abstract notion has become one of the most important areas of modern astrophysics. Today, scientists have devised ingenious ways to observe black holes indirectly, such as by studying the orbits of stars around unseen objects or capturing the gravitational waves emitted when black holes collide. Each new discovery about black holes pushes the limits of our technological capabilities, allowing us to peer deeper into the cosmos and better understand the most extreme environments in the universe. The interplay between speculative theory and empirical research is a dynamic process that constantly reshapes the way we view the universe. As new ideas emerge, they refine our existing hypotheses and force us to reconsider long-held assumptions. This iterative process is a hallmark of scientific progress, where creativity, curiosity, and skepticism drive us toward new frontiers. By questioning established knowledge, astrophysicists continually expand the boundaries of our understanding, uncovering the mysteries of the cosmos and reshaping our place within it. Among the most tantalizing phenomena that have captured the attention of both scientists and the general public are unexplained signals from deep space. These signals, often characterized by bursts of radio waves or pulses of light, have sparked speculation about the existence of extraterrestrial life or unknown astrophysical phenomena. Some of these signals repeat at regular intervals, while others appear just once, each instance raising new questions. One of the most famous examples is the WOW signal, which was recorded in 1977. This strong, narrowband radio signal lasted for 72 seconds and came from the direction of the constellation Sagittarius. Despite extensive follow-up efforts, the source of the WOW signal has never been identified. Its origin remains a mystery, fueling theories that it could be an advanced form of communication from an alien civilization, or, alternatively, a natural event like a comet or a pulsar, misinterpreted due to its rarity. When scientists detect such signals, they employ a range of methods to analyze them. They carefully examine the frequency, duration, and periodicity of the signals, looking for patterns that might suggest either intelligent design or a natural source. The search for extraterrestrial intelligence, or SETI, involves cross-referencing these signals with known cosmic phenomena to ensure they are not simply noise from human-made sources. The ultimate goal is to determine whether these signals represent something truly extraordinary, an indication that we are not alone in the universe, or whether they are the result of yet another unknown astrophysical process. However, the search for extraterrestrial signals is fraught with challenges. The universe is a vast and complex tapestry filled with a wide array of natural phenomena. Events like supernovae, pulsars, and gamma-ray bursts follow predictable patterns that are easy for scientists to identify. But the search for alien signals requires distinguishing between these natural occurrences and potential messages from extraterrestrial civilizations. This is no easy task, as the signals we are looking for must stand out from the background noise of the cosmos. Researchers use advanced algorithms and machine learning techniques to sift through vast amounts of data, searching for signals that exhibit non-random patterns. A signal that repeats in a precise, predictable way could suggest an artificial origin, especially when compared to the chaotic nature of most natural cosmic events. The WOW signal, which was received in 1977, remains an iconic example of the difficulty in distinguishing between natural and artificial signals. The signal came from a region near the constellation Sagittarius and was notable for its unique frequency and intensity. Its unusual characteristics led to widespread speculation that it could be of extraterrestrial origin, though no definitive explanation has ever been found. The WOW signal remains one of the most enduring mysteries of modern science, symbolizing both the promise and the challenges of searching for life beyond Earth. As we continue to explore the cosmos and search for answers, unexplained signals serve as a reminder of the vastness and complexity of the universe. Each new anomaly presents an opportunity for discovery, pushing the boundaries of our technology and sparking new avenues of research. Whether these signals come from distant stars, from alien civilizations, or from previously unknown astrophysical phenomena, they offer a glimpse into the unknown, urging us to continue our quest for understanding in a universe that is as mysterious as it is infinite. Despite years of exhaustive searching and technological refinement, the question of whether humanity has detected signals from extraterrestrial civilizations remains unanswered. While countless efforts have been made, no definitive evidence has surfaced to confirm the existence of intelligent life beyond Earth. Still, the pursuit continues, propelled by the curiosity that drives scientists to explore the cosmos. As our tools and understanding evolve, so too does our ability to peel back the layers of cosmic noise that obscure the faintest whispers from distant civilizations. This endeavor, part scientific exploration, part philosophical quest, has sparked an insatiable desire to bridge the gap between the known and the unknown. It is a journey both exhilarating and fraught with complexity, as it forces us to rethink our place in this vast, magnificent universe. Around the globe, researchers are deploying cutting-edge technology to probe the depths of space, searching for signs that might indicate the presence of extraterrestrial intelligence. One of the most powerful tools in this search is the radio telescope, an instrument designed to capture and study the radio waves emitted by distant celestial objects. Facilities like the Arecibo Observatory, which tragically collapsed in 2020, and the Green Bank Observatory in West Virginia, USA, have long been at the forefront of these efforts. These massive dishes, stretching to impressive diameters, are capable of detecting even the faintest radio emissions, signals that might be artificially generated by an advanced alien civilization. The search is not limited to just radio waves. Optical telescopes, capable of detecting light, are increasingly playing a significant role in the search for extraterrestrial intelligence. These telescopes can capture signals in the form of laser pulses, which could potentially be emitted by advanced extraterrestrial technologies. By detecting these faint yet highly concentrated beams of light, astronomers hope to uncover evidence of alien communication or even interstellar signaling. However, the vastness of space presents a unique challenge. The sheer amount of data generated by these observatories is astronomical, making it increasingly difficult to sift through the information manually. Thankfully, recent advancements in machine learning and artificial intelligence are offering new hope. By applying sophisticated algorithms, scientists can now identify patterns within the immense noise of space, distinguishing between mundane cosmic phenomena like pulsars and quasars, and more intriguing anomalies that could indicate an artificial origin. These technologies allow for a level of efficiency and precision in data analysis that was previously unimaginable, dramatically speeding up the process of detection. The pursuit of extraterrestrial intelligence, often referred to as SETI, search for extraterrestrial intelligence, is no longer just the domain of radio astronomers. Thanks to this new wave of technological innovation, a multifaceted approach is being employed. Radio telescopes work in tandem with optical instruments, and machine learning aids in the analysis of vast data sets, creating a comprehensive strategy that maximizes the chances of detecting any artificial signals that might be lurking in the cosmic noise. The line between natural cosmic phenomena and the potential for artificial signals is not always easy to draw. Scientists are faced with the daunting task of distinguishing between the sounds of distant stars, the quiet hum of galaxies, and something far more extraordinary, signals that may have originated from intelligent beings millions, even billions of light years away. Each anomaly detected, no matter how faint, offers a glimpse of possibility, a tantalizing hint that we might not be alone in the universe. As we push forward into this uncharted territory, it becomes clear that the search for extraterrestrial life is about more than just finding answers. It's about the hope that, out there in the endless expanse of space, we might finally make contact with those who share our desire to explore the unknown. With each technological breakthrough, the boundary between science fiction and reality continues to blur. The quest for extraterrestrial intelligence is not merely a search for signals. It's a search for connection, a yearning to understand the mysteries that lie beyond our own world. Satellite technology has become an indispensable tool in our quest to explore the universe, with space-based observatories like the Kepler Space Telescope playing an essential role in revolutionizing our understanding of distant worlds. By detecting exoplanets located far beyond our solar system, these advanced telescopes offer us a glimpse into the potential for life elsewhere in the cosmos. Kepler's groundbreaking discoveries don't stop at finding planets. They also allow scientists to scrutinize the atmospheres of these planets, analyzing the chemical makeup of their atmospheres in search of patterns that could signal the presence of life. Through the detection of unusual absorption patterns, those that might suggest industrial pollution, scientists are not only exploring the potential for alien life, but they are gathering indirect, yet incredibly compelling, evidence of its existence. The technology we now possess is nothing short of cutting edge, and it's propelling humanity closer than ever to answering one of the most profound questions ever posed. Are we alone in the universe? This ongoing exploration is invigorated by the famous Fermi paradox, a question that has puzzled scientists and thinkers for decades. If, as the numbers suggest, the universe is brimming with potentially habitable planets, why have we not yet encountered any signs of intelligent extraterrestrial civilizations? Enrico Fermi, the brilliant physicist, first posed this conundrum during a casual conversation in the 1950s, a question that has since sparked a vast field of inquiry. The sheer scale of the universe, with billions of stars and an unimaginable number of planets, strongly implies that intelligent life should be widespread. However, despite decades of searching, scientists have found no definitive signs or signals indicating that we are not alone. This mystery has captivated the scientific community and beyond, fueling numerous projects designed to detect extraterrestrial signals. The search for extraterrestrial intelligence, SETI, for instance, uses powerful radio telescopes to scan the cosmos for any patterns that could suggest advanced civilizations attempting to communicate across the vast expanse of space. These efforts are driven by one central question. If intelligent life exists, why haven't we heard from it? Various theories have emerged to explain the Fermi paradox, influencing the direction of scientific searches. One possibility is that extraterrestrial civilizations could be so far away in space, or so far back in time, that their signals simply haven't reached us yet. Another theory posits that their technology might be so different from our own that we fail to recognize their attempts at communication. Alternatively, some researchers argue that the rarity of advanced civilizations could be due to the tendency for civilizations to self-destruct before they achieve the technological capabilities necessary to broadcast their presence across the stars. The search for extraterrestrial signals is an ongoing, multifaceted adventure that blends science with philosophy. Every moment spent scanning the heavens is not just an effort to detect other forms of life, but also a reflection on our own place in the cosmos. In a sense, the quest for extraterrestrial signals has become as much about understanding humanity as it is about seeking other life forms. It's a journey that stretches the limits of our imagination and knowledge. Within this vast, unexplored expanse, certain mysterious signals have captured the attention of scientists, fueling a host of theories and debates. One of the most famous of these is the phenomenon of fast radio bursts, FRBs. These brief yet powerful pulses of radio frequency, originating from distant regions of the universe, are unlike anything we've observed before. While some researchers speculate that FRBs could be the result of neutron stars, specifically magnetars, a type of neutron star with an incredibly strong magnetic field, Others suggest that these bursts may have an extraterrestrial origin, though the cause remains elusive. Another intriguing signal known as the WOW signal was detected in 1977 by astronomer Jerry R. Amon while he was analyzing data from the Big Ear radio telescope. The signal, which lasted for 72 seconds, came from the direction of the constellation Sagittarius and has never been fully explained. Its narrowband radio frequency and its apparent uniqueness continue to spark excitement and speculation. Was it a signal from an alien civilization, or could it be the result of some natural cosmic phenomenon we still don't understand? The specificity of the signal has captured the imagination of scientists and non-scientists alike, fueling a long-standing mystery. More recently, in 2020, a signal originating from a galaxy approximately 3 billion light-years away caught the attention of researchers. The signal, characterized by a pattern of repeating radio waves, raised the possibility of advanced technology from another civilization, although no definitive explanation has been found. The quest to uncover the source of this enigmatic signal remains a compelling mystery, one that continues to inspire curiosity and further exploration. In the realm of gravitational waves, another significant discovery occurred in 2017 with the detection of GW170817, the first ever observation of a neutron star merger. This cosmic event not only produced gravitational waves but also emitted electromagnetic radiation, providing a groundbreaking opportunity to study the universe from both a gravitational and light-based perspective. The merger's significance has reshaped our understanding of cosmic events, pushing the boundaries of our knowledge and deepening our appreciation for the complexity of the universe. As researchers continue to probe these phenomena, each unanswered question serves to propel us further into the mysteries of the cosmos. Cultural perceptions and media portrayals of space exploration have played a crucial role in shaping public interest in the cosmos and the search for extraterrestrial life. From ancient civilizations charting the stars to the modern-day fascination with science fiction, our relationship with the universe is profoundly intertwined with our culture. The stories we tell, whether through mythology, literature, or art, serve as a lens through which we view the cosmos. These narratives evoke wonder and curiosity, compelling us to venture further into space and explore its mysteries. Media representations, particularly in film and television, captivate the public's imagination and spark interest in scientific inquiry. Movies that showcase alien encounters or epic space adventures can inspire viewers to learn more about real astronomical phenomena. Documentaries that explore recent discoveries in astrophysics or delve into the search for extraterrestrial life serve to educate the public, feeding their fascination with the unknown while making complex scientific concepts more relatable and accessible. In this way, the media plays a vital role in translating the abstract wonders of the universe into compelling stories that inspire curiosity and scientific exploration. The advent of social media platforms has profoundly reshaped how information spreads and how it is consumed. No longer confined to academic journals or specialized conferences, scientific discoveries and insights are now shared directly with a vast global audience. The power of viral content allows groundbreaking discoveries, whether they involve mysterious signals from space or new understandings of the cosmos, to ignite public curiosity and fuel widespread discussion. This dynamic exchange between scientists, educators, and the public fosters a community of eager minds, all united in their fascination with the mysteries of the universe. It also breaks down the traditional barriers that have separated expert knowledge from the everyday person, making scientific inquiry more accessible than ever before. A prime example of this phenomenon can be found in the case of the WOW signal, an unexplained radio burst detected in 1977. This signal, still a subject of intrigue today, captivated not only scientists, but also the broader public. The case of the WOW signal illustrates how cultural narratives and media portrayals can shape the way we interpret unexplained cosmic signals. Such events often spark a wide range of speculations, from serious scientific analysis to theories about extraterrestrial intelligence. As information travels faster and more widely through social media, these speculations gain momentum, pushing even more people to ask big questions about the nature of life beyond Earth. This blending of science, media, and public engagement has created a rich and dynamic tapestry of interest. Cultural perceptions shaped by popular media provide the backdrop for how we view these cosmic enigmas. At the same time, direct engagement on platforms like Twitter, Facebook, and Reddit allows scientists to engage with the public in real time, answering questions and encouraging deeper exploration of the unknown. The result is a vibrant dialogue between experts and curious minds that extends well beyond traditional academic circles. However, the pursuit of understanding these mysterious signals is far from an individual endeavor. It requires international collaboration, especially in the fields of astronomy and astrophysics. Signals from space, ranging from fleeting radio pulses to unusual light patterns, often come from distant, enigmatic cosmic phenomena. Deciphering their origins requires the combined expertise, technology, and resources of many nations. No single organization or country, no matter how advanced, can tackle these questions alone. By pooling their resources, countries can share data, coordinate efforts, and strengthen their technological capabilities. For example, nations with cutting-edge radio telescopes can join forces with those possessing advanced optical observatories and space-based instruments. This collective approach allows scientists to approach cosmic signals from multiple angles and gather data across a range of wavelengths. When a peculiar signal is detected, a coordinated response from multiple observatories can quickly direct instruments to the source, gathering essential data that might otherwise remain elusive. Such collaboration often leads to faster discoveries and more accurate interpretations, enhancing our collective understanding of these cosmic mysteries. In addition to technological collaboration, international partnerships also foster the exchange of ideas and scientific methodologies. Through global conferences and joint research initiatives, scientists from diverse backgrounds and cultures can bring fresh perspectives to long-standing questions. This cross-pollination of knowledge accelerates the process of hypothesis development and experimentation, allowing for the testing of innovative theories and the refinement of existing ones. For instance, the detection of fast radio bursts, a phenomenon that has puzzled astronomers for years, has benefited from this kind of international collaboration, where different scientific communities contributed their theoretical models, leading to breakthroughs in understanding. These global collaborations do more than advance our scientific knowledge. They also serve to inspire public interest in space science. Large-scale projects such as the European Space Agency, ESA, and the Square Kilometre Array, SKA, illustrate the collective human effort to unlock the mysteries of the universe. They show that the pursuit of these cosmic questions is not limited to individual nations, but is a shared endeavor that resonates with the entire human race. In this sense, tackling the enigma of unexplained signals from space becomes a journey that connects people across borders, transcending national boundaries and inspiring a global quest for knowledge. On Earth, the study of terrestrial anomalies can also provide valuable insights into cosmic phenomena. These earthbound anomalies, which include strange natural events like lightning or auroras, may hold the key to improving our detection methods and instruments for analyzing cosmic signals. By examining how these terrestrial phenomena emit electromagnetic radiation, scientists can develop more accurate models for identifying and distinguishing genuine signals from space. For example, the electromagnetic signatures of lightning and auroras bear a resemblance to those produced by distant cosmic phenomena, such as black holes or pulsars. By studying the behavior of these terrestrial anomalies, scientists can refine their detection algorithms, ensuring that they can more effectively filter out background noise and focus on genuine cosmic signals. Moreover, the technologies developed for monitoring earthbound phenomena are often adapted for use in space observation. Instruments designed to study local atmospheric events may be repurposed for analyzing data from distant stars or galaxies. This interplay between terrestrial and cosmic research creates a more comprehensive understanding of the universe, as insights gained from one field can directly enhance the other. As technology advances, artificial intelligence, AI, is playing an increasingly significant role in the detection and analysis of cosmic signals. Traditionally, this task required hours of painstaking work by human researchers, sifting through enormous datasets from telescopes and sensors. Now, AI systems can analyze vast amounts of data in a fraction of the time, uncovering patterns and anomalies that might elude even the most experienced astronomer. One of the most promising applications of AI in astrophysics is its ability to classify different types of cosmic phenomena. By training machine learning models on existing data, AI systems can learn to recognize the distinctive signatures of known astrophysical events, such as supernova or pulsar emissions. When a new signal is detected, these AI systems can quickly determine whether it fits into one of these established categories or if it represents something entirely unknown. This ability is particularly crucial when analyzing data from radio telescopes that monitor the sky for fast radio bursts, intense bursts of radio frequency emissions that last just milliseconds but carry enormous scientific potential. The power of AI lies not only in its ability to sift through data, but also in its capacity to generate hypotheses and suggest new avenues of investigation. In this way, AI is transforming the way we approach the study of the cosmos, enabling us to detect and understand cosmic phenomena more efficiently and with greater precision. The future of space exploration, guided by both human ingenuity and artificial intelligence, holds immense promise for unraveling the mysteries that have long captivated humanity. Artificial intelligence is reshaping the landscape of scientific discovery, particularly in the realm of space exploration. One of its most transformative contributions is in enhancing the speed and efficiency of data processing. Modern observatories, which generate enormous volumes of data daily, produce petabytes of information that can be overwhelming to process manually. With the assistance of AI, this mountain of data becomes much more manageable. AI algorithms can quickly sift through massive data sets, identifying potentially groundbreaking signals and events with precision. This rapid analysis not only accelerates the identification of interesting phenomena, but also allows scientists to focus their efforts and resources on the most promising leads, whether they are potential signs of extraterrestrial intelligence or previously unrecognized cosmic events that warrant deeper study. Furthermore, AI doesn't just streamline the detection process, it also plays a crucial role in the interpretation of cosmic signals. Through predictive modeling techniques, AI can simulate a wide range of cosmic events and the types of signals they might produce. By replicating conditions that occur in space, AI helps scientists gain a deeper understanding of the environments in which these signals emerge. This enhances their ability to form more accurate hypotheses regarding the origins of such signals, opening up new avenues for investigation. With each advancement in artificial intelligence, its role expands, transforming it from a mere tool to a collaborative partner in the search for answers to the universe's deepest mysteries. However, as AI aids in the discovery of unexplained signals from space, it also raises a complex set of ethical considerations. Perhaps the most intriguing and contentious aspect of this endeavor is the search for extraterrestrial intelligence, ETI. When scientists detect enigmatic signals that could potentially originate from intelligent civilizations beyond our planet, they are thrust into a moral landscape that presents difficult questions. One of the most immediate concerns is how humanity should communicate with these potential extraterrestrial beings. Should we send messages or responses to these distant civilizations, or should we remain silent? This question sparks a nuanced debate within the scientific community. On one hand, proponents argue that initiating contact could lead to mutually beneficial relationships, fostering understanding between different intelligent species across the cosmos. On the other hand, there are serious concerns about the risks of such an action. What if these civilizations possess technological capabilities far beyond our own? Could reaching out inadvertently provoke a harmful interaction or misunderstanding? The potential dangers are numerous, and they demand careful consideration. Moreover, the discovery of extraterrestrial intelligence could have far-reaching consequences for humanity on Earth. The mere knowledge of such beings could provoke profound shifts in our societal, religious, and philosophical paradigms. How we respond to these revelations will be pivotal in shaping the future of human society. Will the knowledge of extraterrestrial life unite us in wonder and awe, propelling us toward a collective pursuit of cosmic truth? Or will it fracture us, sowing discord and fear as individuals and groups struggle to reconcile this discovery with their deeply held beliefs about our place in the universe. These questions are not merely hypothetical. They represent real challenges that humanity must grapple with as we venture further into the unknown. In addition to these philosophical and social considerations, the scientific pursuit itself carries its own ethical responsibilities. Researchers involved in the study of extraterrestrial signals are tasked with a duty to remain transparent about their findings while ensuring that their work does not cause unnecessary anxiety or generate unrealistic expectations. The integrity of scientific inquiry demands that discoveries be approached with caution and objectivity. Each unexplained signal represents not just a tantalizing piece of data, but a potential shift in our understanding of the universe. As such, it is essential that scientists share their knowledge responsibly, recognizing the profound implications that such discoveries may have on society. As scientists continue to explore the cosmos, they employ a diverse array of methodologies, many of which diverge significantly from traditional research approaches. Observational techniques, for instance, play a central role in the investigation of cosmic anomalies. Space telescopes and radio observatories are deployed to capture electromagnetic signals from distant celestial bodies. Instruments like the Hubble Space Telescope have provided breathtaking images and invaluable data, unveiling galaxies, nebula, and even exoplanets that are billions of light years away. These observations offer a window into the far reaches of the universe, enabling scientists to gather crucial information about phenomena that are otherwise beyond our direct grasp. In addition to observational methods, computational modeling and simulations have become indispensable tools in the study of the cosmos. By using powerful computers, researchers can replicate the conditions of the early universe, model the formation of black holes, or simulate the dynamics of dark matter. These simulations allow scientists to explore cosmic events that cannot be directly observed, such as supernova explosions or the mergers of neutron stars. Although these events occur at vast distances or even in environments that are challenging to replicate on Earth, simulations offer a way to visualize their behavior and gain insights into the fundamental forces that shape our universe. Another critical aspect of modern cosmic research is the interdisciplinary approach that many scientists take. The study of the universe is increasingly seen as a collaborative effort that brings together experts from a range of fields, including physics, chemistry, astronomy, and even geography. These interdisciplinary teams often consist of astronomers, particle physicists, cosmologists, and other specialists who bring diverse perspectives to the table. This collaborative approach enriches the research process, enabling scientists to tackle complex problems from multiple angles. For example, the detection of gravitational waves, ripples in space-time, caused by the acceleration of massive objects, was made possible through the combined efforts of physicists, engineers, and astronomers. Facilities like the Laser Interferometer Gravitational Wave Observatory LIGO have provided groundbreaking data, marking a major milestone in the study of the cosmos. The interdisciplinary nature of cosmic research is a testament to how advancements in one field can lead to breakthroughs in another. It underscores the interconnectedness of scientific knowledge and the importance of collaboration in pushing the boundaries of what we know about the universe. With each new discovery, whether through AI-assisted data analysis or the development of new observational techniques, we move one step closer to understanding the mysteries of the cosmos and our place within it. As technology continues to evolve, so too does the potential for deeper exploration and greater insights into the wonders of the universe. The journey is far from over, and with each new piece of data, we come closer to unraveling the complex tapestry of the cosmos. In the realm of cosmic exploration, the scientific community's commitment to collaboration and peer review is unwavering. Unlike traditional fields of study, where research often centers around more focused, localized inquiries, the investigation of cosmic anomalies demands a broader approach. These phenomena, which challenge our understanding of the universe, often require the pooling of knowledge, expertise, and resources from a wide network of institutions and countries. This collaborative spirit not only sparks innovation, but also ensures that findings are subjected to rigorous testing and validation. ultimately bringing us closer to deciphering the vast mysteries of the cosmos. Through this unique approach, scientists can explore complexities and anomalies that would remain beyond our grasp if left to a singular institution or nation. The continuous dialogue between different scientific minds allows for a more comprehensive and detailed investigation into the nature of the universe, shedding light on concepts that were once thought to be insurmountable. As researchers work together across borders and disciplines, they collectively unravel phenomena that could otherwise remain hidden in the depths of space. However, this exploration of the unknown is not without its challenges. The funding and resource allocation required to delve into these cosmic enigmas are critical. Without adequate financial backing, even the most promising and thought-provoking research might remain grounded in the realm of theory, never materializing into actionable exploration. Agencies such as NASA, space agencies from other countries, universities, and private enterprises are tasked with deciding which projects receive funding, often weighing potential breakthroughs against the likelihood of immediate results. In this competitive environment, even groundbreaking ideas may not always receive the attention they deserve if they are perceived as lacking short-term applicability. The competition for limited funding becomes even more complex when you consider the myriad of scientific fields vying for financial resources. While many researchers seek to unravel the mysteries of space, exploring concepts like dark matter or investigating the origins of the cosmic microwave background radiation, they find themselves competing with more pressing issues such as climate change, public health crises, and technological advancements in other domains. This competitive landscape creates a delicate balancing act where innovative projects in space exploration may struggle to secure the necessary resources. Resource allocation, of course, extends beyond funding alone. The tools and technologies required to conduct high-level cosmic research, such as advanced telescopes, space probes, and particle colliders, are expensive to develop, maintain, and operate. These instruments define the scope of investigations, allowing scientists to probe the farthest reaches of space. However, when resources are constrained, decisions must be made regarding which projects to prioritize. As a result, research that holds the promise of uncovering profound insights into the universe may be placed on the back burner in favor of initiatives that promise more immediate, quantifiable data. This tension highlights the difficulties faced by researchers in the pursuit of knowledge, as they work to uncover phenomena that may take decades to fully understand. Despite these challenges, there has been a noticeable shift in recent years, fueled by advancements in technology and a growing recognition of the importance of foundational research. Public interest in space exploration has been steadily rising, creating a favorable environment for increased governmental and commercial support for ambitious scientific initiatives. As more people become fascinated by the wonders of space, resources for exploring unexplained cosmic phenomena have become more readily available, offering new opportunities for researchers to push the boundaries of human knowledge. Yet, as funding and resources have increased, so too has the awareness that the quest for knowledge must be guided by more than just curiosity. It must also be supported by the ability to secure the means necessary to pursue it. In this changing landscape, the role of scientific inquiry is not only to seek answers, but to engage the public, generate interest, and inspire new avenues of exploration. As the public becomes more involved in the process, it can lead to fresh perspectives and ideas that might otherwise have gone unnoticed. In the pursuit of knowledge, scientific errors and oversights are inevitable, yet they play an essential role in the continued growth of our understanding of the universe. When researchers encounter unexpected results, whether they involve strange cosmic phenomena or anomalies in their data, they are presented with critical decisions. Should they accept the findings as they are? Should they revise existing theories to accommodate these anomalies? Or should they dive deeper, seeking new explanations for the unexpected? Often, these errors serve as catalysts for further investigation. They prompt vital questions that can lead to breakthroughs and the development of new scientific theories. One of the most striking examples of this process is the discovery of dark matter. Early observations of galaxy rotation revealed that galaxies were spinning at such high speeds that, based on our current understanding of gravity, they should have disintegrated. This discrepancy pointed to the existence of a mysterious, unseen substance that exerts gravitational influence without being detectable by conventional means. This oversight in early gravitational theory led to the formulation of the dark matter hypothesis, a groundbreaking concept that has since shaped much of our understanding of the cosmos. These scientific errors are not confined to theoretical missteps. They often arise from the limitations of the instruments and methods available at the time. Early telescopes, for example, introduced biases in the way data was interpreted, creating incomplete or distorted views of the universe. The process of refining these tools and techniques often involves overcoming these initial inaccuracies, which ultimately results in more precise and detailed models of the cosmos. The errors and missteps encountered along the way underscore the importance of peer review, reproducibility, and ongoing scrutiny in science, as each mistake presents an opportunity to correct course and develop a deeper understanding of the world around us. In this way, errors in scientific research act as vital signposts, reminding us that our understanding of the universe is not fixed. Instead, it is a constantly evolving process, one that is shaped by trial, error, and the occasional stroke of serendipity. Every mistake, every unexpected anomaly pushes the boundaries of our knowledge and invites further exploration. As a result, the cosmos continues to reveal its secrets to those willing to dig deeper and challenge existing paradigms. Public engagement and outreach also play a pivotal role in advancing research into unexplained cosmic phenomena. By communicating their work to the public, scientists not only share their findings, but foster an environment of curiosity and exploration. This dialogue helps bridge the gap between complex, abstract scientific endeavors and the broader community, encouraging individuals to ask questions, seek answers, and pursue their own inquiries into the mysteries of the universe. Public interest in space and science can lead to new ideas, new research directions, and even collaborations that push the boundaries of what we know about the cosmos. As the scientific community continues to engage with the public, the possibilities for new discoveries become endless, whether it's through the sharing of ideas, the challenging of old assumptions, or the discovery of unexpected phenomena. The journey toward unraveling the universe's greatest mysteries is an ongoing collective endeavor, one that requires collaboration, perseverance, and a willingness to embrace the unknown. Public interest plays a pivotal role in fueling both funding and resources for the investigation of unexplained phenomena. When researchers actively engage with the public through outreach initiatives, they not only raise awareness, but also ignite excitement about the mysteries of the unknown. This enthusiasm from the general public attracts potential investors, sponsors, and philanthropists eager to support groundbreaking scientific endeavors. A captivated audience doesn't just provide financial backing, it creates a broader cultural atmosphere of curiosity and inquiry. This environment encourages researchers to venture beyond traditional boundaries and reconsider anomalies that might have been previously dismissed or overlooked. Furthermore, when researchers include the public in discussions surrounding these unexplained phenomena, they benefit from a diverse range of perspectives. Such engagement brings new insights that can challenge existing assumptions, as well as identify societal concerns, ethical dilemmas, and common misconceptions. These insights are often invaluable for guiding the direction of scientific work. For instance, when the public is informed about a specific anomaly, they might highlight certain aspects that researchers had not yet considered, leading to a more comprehensive and nuanced understanding of the phenomenon. This collaborative dialogue has the power to not only enrich the scientific process, but also to broaden the scope of inquiry. Ultimately, the synergy between public engagement and scientific research has the potential to accelerate discoveries and deepen our collective understanding of the universe's most profound mysteries. By fostering a spirit of inquiry and collaboration, outreach initiatives transform the scientific process into a shared journey, one where individuals from all walks of life can contribute to exploring the unknown. In recent years, we have witnessed a series of remarkable breakthroughs in astrophysics, offering extraordinary new insights into some of the deepest questions about our universe. Perhaps one of the most groundbreaking advancements in the field has been the detection of gravitational waves, first observed in 2015. The continued study of these ripples in space-time has opened an entirely new chapter in our understanding of catastrophic cosmic events such as merging black holes and neutron stars. The data obtained from these violent phenomena are reshaping our view of the universe's evolution as well as the fundamental physics governing its most extreme environments. Another significant leap forward has been made in the study of exoplanets, planets located outside our solar system. With the advent of cutting-edge telescope technologies, such as the James Webb Space Telescope, astronomers are now able to analyze the atmospheres of distant worlds with unparalleled precision. This research is key to understanding whether life could exist beyond Earth. For example, the detection of water vapor in the atmospheres of several exoplanets has ignited thrilling discussions about the potential for habitable environments in other cosmic neighborhoods. These discoveries are helping to redefine our search for life in the universe, moving us closer to answering one of humanity's most profound questions: are we alone? Meanwhile, the mapping of dark matter has also progressed significantly in recent years. Dark matter, which accounts for roughly 27% of the universe's mass, remains one of the greatest mysteries in astrophysics. Through sophisticated simulations and observational data, such as those provided by the Dark Energy Survey, scientists are beginning to unlock its role in shaping the formation and behavior of galaxies. Understanding dark matter is crucial for developing a complete picture of the universe's structure and evolution. Equally fascinating are the ongoing investigations into cosmic microwave background radiation, the faint remnants of energy from the Big Bang itself. This radiation is a crucial tool for studying the universe's infancy and its rapid expansion in the moments following the Big Bang. New measurements of cosmic inflation, the incredibly fast expansion of space that occurred shortly after the Big Bang, are providing clearer insights into the origins of the universe. By piecing together this intricate puzzle, researchers are slowly but surely constructing a more coherent narrative of the cosmos's history, shedding light on some of the most elusive cosmic enigmas. Astrophysics draws upon a vast array of scientific disciplines, including physics, astronomy, mathematics, chemistry, and engineering, to unravel the mysteries of the universe. This interdisciplinary approach is crucial in addressing unexplained phenomena such as dark matter, fast radio bursts, and gravitational waves. Each discipline brings its own unique tools and perspectives, allowing scientists to approach these cosmic puzzles from multiple angles and develop more comprehensive solutions. For instance, physicists refine theories of gravity and quantum mechanics, which form the bedrock for understanding celestial mechanics, while astronomers use advanced telescopes and observational techniques to gather data from distant galaxies, stars, and black holes. This fusion of expertise enables scientists to develop innovative methods of inquiry, allowing them to reinterpret and reanalyze data that may have initially seemed inexplicable. By working together across disciplines, researchers are creating a more complete and nuanced picture of the universe's mysteries, pushing the boundaries of human knowledge and helping to unlock some of the most profound questions of our existence. The exploration of the cosmos is not just a matter of launching spacecraft into space or looking through telescopes. It is a multifaceted journey that involves an intricate interplay of several scientific disciplines. Chemistry, for instance, plays an essential role in our ability to unravel the mysteries of the universe. By analyzing the spectra, the unique light emitted or absorbed by substances, scientists are able to detect complex molecules in the atmospheres of distant exoplanets. Chemists help identify the very building blocks of life that might exist beyond Earth. This ability to detect and study the chemical compositions of celestial bodies not only expands our understanding of the universe, but also sparks new questions and hypotheses about life elsewhere in the cosmos. This interdisciplinary synergy is key to broadening the investigative capabilities of researchers. It is this collaboration between fields like chemistry, engineering, and physics that allows us to probe the deepest questions about the nature of the universe, As scientists share knowledge and ideas across disciplinary boundaries, the questions we ask evolve, often leading to unexpected breakthroughs. Engineering, too, plays a pivotal role in space exploration. The development of advanced technologies, from powerful space telescopes to sensitive instruments that measure cosmic radiation, is critical in turning scientific theories into real-world discoveries. The collaboration between these disciplines fosters a dynamic and ever-evolving research environment. The merging of different perspectives allows for innovative solutions to long-standing scientific dilemmas, creating a fertile ground for new ideas and technologies that push the boundaries of what we know. This spirit of cooperation accelerates the process of discovery, bringing us ever closer to unlocking the universe's deepest secrets. Through these interdisciplinary efforts, we continue to drive forward in our quest for knowledge, constantly expanding the frontiers of science. Several organizations and research institutions are at the forefront of this scientific endeavor. Among the most prominent is NASA, the United States Space Exploration Agency. NASA has been instrumental in advancing our understanding of cosmic phenomena with a broad array of missions aimed at exploring some of the most profound mysteries of the universe. These include the study of black holes, dark matter, and gravitational waves. Missions such as the Hubble Space Telescope, which has provided stunning images of distant galaxies and nebula, and the upcoming James Webb Space Telescope, are designed to push the boundaries of our understanding of the universe's origins, structure, and evolution. Another key player is the European Space Agency, ESA, which frequently collaborates with NASA on ambitious projects. One such collaboration is the Laser Interferometer Space Antenna, LISA, which aims to detect gravitational waves, ripples in spacetime caused by massive cosmic events such as the collision of black holes. LISA's mission has the potential to revolutionize our understanding of gravity and the very fabric of the universe. By detecting and analyzing these gravitational waves, ESA hopes to unveil new dimensions of our cosmos, offering a deeper understanding of the forces that govern it. In addition to these agencies, the Large Hadron Collider, LHC, operated by CERN, the European Organization for Nuclear Research, explores cosmic anomalies from a particle physics perspective. The LHC smashes particles together at unprecedented energies, searching for evidence of unknown particles and interactions that could shed light on mysteries like dark matter. These high-energy collisions offer a glimpse into the fundamental building blocks of the universe, challenging our most basic assumptions about matter and energy. The ongoing experiments at CERN delve deeper into the very fabric of reality, seeking answers to questions about the nature of existence itself. The American Institute of Physics and various universities across the world also contribute significantly to the cosmic exploration effort. Their research often focuses on the theoretical aspects of cosmology, quantum mechanics, and astrophysics, expanding our conceptual frameworks and pushing the boundaries of what is considered possible in our understanding of the universe. These institutions, through their diverse missions and goals, play a crucial role in advancing our collective knowledge about the enigmatic universe in which we live. A key element that shapes the conversation around cosmic exploration is the peer-reviewed publication process. In scientific research, peer-reviewed journals are the cornerstone of credibility and rigor. By subjecting research findings to the scrutiny of experts in the field, peer-reviewed publications ensure that only the most reliable, accurate, and well-supported work enters the scientific discourse. This process not only improves the quality of research, but also promotes transparency, as scientists must disclose their methods, data, and sources for critical evaluation. When new findings are published, they are rigorously analyzed by other scientists to ensure that any unusual signals, strange celestial behaviors, or mysterious phenomena are well supported by evidence. This peer review acts as a filter, separating scientifically sound ideas from those lacking sufficient evidence or that may be based on faulty data. When anomalies such as unexplained cosmic signals or unusual behavior in distant stars are reported, they are carefully examined to determine whether they represent new, groundbreaking discoveries or whether they are simply the result of observational errors or technological limitations. Peer-reviewed articles also serve as reference points for future research, helping scientists build on each other's work. For instance, if the detection of gravitational waves or an unusual exoplanet is reported, other researchers can investigate these findings, furthering the research and refining the understanding of these phenomena. This collaborative effort creates a feedback loop, where each new discovery can lead to additional questions, refining our comprehension of the universe over time. As these discussions evolve, the scientific community plays a central role in shaping the narrative of cosmic exploration. This exchange of ideas is not just confined to the academic sphere. The publication of new research findings often generates public interest, capturing the imagination of people around the world. As a result, these discoveries can attract funding, inspire technological advancements, and ultimately lead to even deeper insights into the mysteries of the cosmos. Peer-reviewed publications, therefore, not only advance scientific understanding, but also act as a catalyst for further exploration. Despite the rigorous nature of scientific inquiry, there are still many controversial and unresolved questions surrounding cosmic exploration. One of the most significant debates concerns the nature of dark matter and dark energy. These elusive substances are believed to make up around 95% of the universe's total mass energy content, but their exact nature remains a profound mystery. While scientists agree on their existence, primarily due to their gravitational effects on visible matter, the true composition of dark matter and dark energy remains one of the greatest enigmas in modern physics. Some theories suggest that dark matter consists of unseen particles, while others propose modifications to our understanding of gravity itself. Another contentious issue is the theory of the multiverse. According to this hypothesis, our universe may be just one of many, each existing simultaneously in a vast multiverse. Some physicists embrace the multiverse theory as a potential explanation for seemingly random cosmic phenomena, suggesting that each universe within the multiverse could have its own set of physical laws. This theory challenges many of the assumptions that have guided cosmology for centuries, and remains a topic of intense debate among scientists. As we continue to explore the cosmos, it is these very debates and unanswered questions that drive scientific inquiry forward. Whether we are peering into the distant reaches of space with the help of sophisticated telescopes or smashing particles together in underground laboratories, the quest to understand the universe is a collaborative, dynamic, and ever-evolving process. Through interdisciplinary cooperation, rigorous research, and the passionate pursuit of knowledge, humanity is steadily uncovering the deep and complex truths of the cosmos. However, critics argue that this theory lacks the empirical evidence necessary to validate it scientifically. They emphasize that, without testable predictions, the concept of the multiverse ventures into the domain of philosophy, rather than remaining within the realm of grounded scientific inquiry. This criticism draws attention to the lack of concrete data that could substantiate such a hypothesis, thereby making it an elusive and speculative idea. The debate intensifies as scientists and philosophers continue to clash over the fundamental nature of the multiverse theory. For some, the concept remains a tantalizing possibility. For others, it's a blind alley without scientific support. The lack of direct evidence and testable predictions leaves the theory in a gray zone, open to speculation and theoretical extrapolation rather than definitive scientific validation. Parallel to this, the search for extraterrestrial life continues to ignite passionate debates, especially when considering the interpretation of evidence that might suggest its existence. Take, for example, the various findings of microbial fossils on Mars, or the potential for life on icy moons like Europa and Enceladus, which might harbor subsurface oceans beneath their frozen exteriors. For some scientists, these discoveries spark the hope that we are closer to finding life beyond Earth, potentially indicating biological processes. However, others exercise caution, warning against premature conclusions in the absence of robust evidence. This creates a delicate balance between cautious skepticism and the excitement of discovery, as the scientific community grapples with the unknown. The ethical dimensions of technological advancements in cosmic exploration also spark significant controversy. As we embark on missions to send humans back to the moon or even to Mars, Questions regarding planetary contamination and the potential for future colonization are becoming increasingly urgent. With the growth of advanced technologies like the James Webb Space Telescope, which offers unprecedented views of distant galaxies, scientists are now faced with not just the technical challenges of exploration, but also the ethical and moral responsibilities that accompany such profound discoveries. The quest to explore the cosmos is not merely an exploration of the unknown, but also a journey fraught with questions about the consequences of our actions, the preservation of other worlds, and the future of our species in the greater cosmic context. As these technologies push the boundaries of what is possible, the intertwining of scientific innovation and ethical considerations will continue to shape the future of cosmic exploration. This dual responsibility, advancing human knowledge while safeguarding the future, will define much of the discourse in space science for generations to come. Scientists approach the inherent uncertainty and ambiguity of unexplained cosmic phenomena with a blend of open-mindedness, rigorous skepticism, and an unwavering commitment to the scientific method. As they explore the mysteries of the universe, they understand that not every question has a simple or straightforward answer, and that very uncertainty is what fuels the pursuit of understanding. The first line of defense in this journey is the scientific method, a systematic approach that prioritizes observation, experimentation, and the careful formulation of hypotheses. By gathering data from cutting-edge instruments such as telescopes, satellites, and other advanced technologies, researchers build the foundation for further understanding. Collaboration plays a vital role in navigating the complex and often bewildering unknown. Scientists from various fields, ranging from astrophysics and astronomy to cosmology, often work together, sharing their findings and perspectives to foster a richer understanding of the phenomena they study. This interdisciplinary approach is essential when confronting new cosmic mysteries. Take, for instance, the detection of a peculiar signal from distant galaxies. When such anomalies arise, experts from various scientific disciplines come together, pooling their knowledge to analyze the data, propose potential explanations, and explore how this new information fits or challenges current scientific theories. Moreover, many scientists embrace the unknown as an opportunity for discovery, rather than viewing it as a setback. Rather than seeing unanswered questions as a failure, they view them as an invitation to dig deeper, refine existing theories, and even develop entirely new ones. For example, the ongoing quest to understand dark matter and dark energy, two of the most profound mysteries in modern physics, has led to groundbreaking advances in both theoretical and experimental science. This openness to curiosity, coupled with the perseverance to explore even the most perplexing questions, often results in groundbreaking ideas and revolutionary breakthroughs. This mindset reflects a crucial characteristic of the scientific community: the constant willingness to question findings and hypotheses. Scientific knowledge is understood to be provisional. New evidence can alter, refine, or even overturn previously accepted theories. This process of hypothesis testing, constant reevaluation, and refinement of ideas creates a dynamic environment in which uncertainty is not feared but embraced. It is this very uncertainty that propels humanity forward, driving us to question the known and venture into the unknown. This spirit of inquiry fosters a sense of adventure and determination in the search for knowledge, one that transcends individual ambition and feeds into the collective human endeavor. The pursuit of understanding the universe's unexplained phenomena shapes humanity's worldview in profound and transformative ways. When scientists encounter anomalies that defy current understanding, such as dark matter, dark energy, or the mysterious patterns observed in the cosmic microwave background radiation, these encounters spark a deep sense of wonder and curiosity. These unexplained phenomena challenge not only existing scientific theories, but also compel us to ask fundamental questions about the very nature of reality itself. What does the universe truly consist of? What laws govern its existence? These questions invite us to dig deeper into the fabric of the cosmos, seeking answers that have profound philosophical and existential implications. Every new discovery that defies explanation fuels this inquiry and creativity. For example, the realization that most of the universe is composed of material we cannot directly see or detect, such as dark matter and dark energy, is both humbling and awe-inspiring. It forces us to confront the limits of our knowledge and the vastness of what remains hidden. In many ways, this knowledge positions us not as masters of the universe, but as humble explorers, grappling with an expansive unknown. This ongoing exploration fosters a sense of unity as humanity begins to perceive itself as part of a larger cosmic narrative. Rather than seeing ourselves as mere observers in an already comprehensible universe, we recognize our role as active participants in an ongoing process of discovery. As we confront these cosmic mysteries, we are prompted to reflect on profound philosophical and existential questions. Are we alone in the universe? If intelligent life exists beyond Earth, what does that mean for humanity's place in the grand scheme of things? These questions force us to reconsider our significance in the universe, encouraging humility and wonder. Furthermore, these challenges also remind us that while we have made incredible strides in understanding the cosmos, much of it remains shrouded in mystery. This duality, our remarkable achievements juxtaposed with our profound ignorance, deeply influences our social and cultural perspectives. It fosters a collective belief that the pursuit of knowledge is not limited by national boundaries or personal interests, but is instead a universal endeavor shared by all of humanity. Ultimately, the journey to understand the unexplained is not only about uncovering answers, but also about forging deeper connections, both within our communities and with the universe itself. As we continue to explore the cosmos and tackle its mysteries, we are constantly reminded that science is not just about finding answers, but also about deepening our shared humanity and our collective understanding of the world around us. As we confront phenomena that stretch the boundaries of our understanding, we are faced with a myriad of philosophical questions. What does it mean to know something? As science advances and uncovers discoveries that challenge conventional wisdom, we are forced to scrutinize the very foundations of our beliefs and the frameworks through which we interpret the universe. Consider the implications of concepts like black holes or quantum entanglement, which not only defy everyday experiences but also challenge classical notions of reality. These mysteries compel us to reconsider our understanding of causality, time, and existence itself. Many of these challenges echo age-old philosophical dilemmas, particularly those related to determinism and free will. Is the universe governed by strict, unyielding laws, or does randomness and uncertainty play a more significant role in shaping the course of events? These questions stretch the limits of human understanding, pushing us to grapple with our place in the cosmos and our ability to influence it. Encountering the unknown also brings ethical concerns to the forefront. If our understanding of the universe is so limited, what responsibilities do we bear in exploring its mysteries? Should there be ethical boundaries in our quest for knowledge? As we unravel the mysteries of dark matter, dark energy, and other cosmic phenomena, we must consider the implications these discoveries might have for the future of humanity. How do we ensure that our pursuit of knowledge remains aligned with moral and ethical integrity, and that we don't inadvertently harm ourselves or the universe we are so eager to understand? These questions will continue to guide and shape our cosmic exploration for years to come. Such phenomena compel us to reflect on our position within the vast expanse of the cosmos. What if, upon further exploration, we find that our understanding is but a small piece of a much grander puzzle? How does that reshape our sense of self? Do we continue to view ourselves as the pinnacle of intelligence in the universe? Or are we simply one thread woven into a colossal, interconnected tapestry? These questions are not just intellectual musings. They embody a profound and often humbling journey that challenges our perception of reality, driving us to reconsider humanity's place in the infinite narrative of existence. The search for knowledge inevitably pushes us toward deeper introspection, urging us to redefine what it means to be human in a universe far greater than we can imagine. Storytelling and art stand as powerful mediums for engaging the public with the enigmatic mysteries of the universe. They do not merely inform, they captivate our collective imagination, transforming complex scientific concepts into accessible and relatable narratives. Through the lens of storytelling, abstract notions like black holes, alien life, or the fabric of time are rendered into compelling, vivid adventures that both fascinate and inspire curiosity. Literature, cinema, and even video games have played pivotal roles in popularizing these cosmic ideas, sparking an insatiable thirst for exploration and discovery. Art, in tandem with storytelling, offers a unique avenue for engaging with the universe on an emotional level. While words and theories describe the cosmos in intellectual terms, art translates these concepts into visual experiences that elicit awe and wonder. Breathtaking portrayals of galaxies, abstract representations of cosmic phenomena, or sculptures capturing the vastness of space allow viewers to feel the beauty and mystery of the universe in ways that pure data cannot. A single painting of the night sky or a striking sculpture can evoke a sense of cosmic awe that mere statistics fail to achieve. Art nurtures a different kind of understanding, one that invites us to feel the universe, not just think about it. Moreover, these creative forms foster dialogue and stimulate new ways of thinking. When people engage with cosmic themes through art or storytelling, they naturally draw personal connections. They begin to ask questions about their own place in the universe, sparking deeper philosophical inquiries and discussions about the nature of existence, science, and the unknown. This dialogue, enriched by diverse perspectives, can open new doors to scientific exploration, guiding individuals to pursue knowledge further. In this sense, storytelling and art are not mere forms of entertainment. They serve as bridges between science and society, connecting the human experience with the vast, complex realities of the universe. They invite everyone, regardless of background, to embark on the shared quest for understanding the intricacies and mysteries of existence. Imagination plays a crucial role in scientific exploration, particularly when confronted with unexplained phenomena. Scientists frequently encounter mysteries that challenge their current understanding of the universe. In these moments, creativity is not just a helpful tool, it is essential. Imagination allows researchers to hypothesize, to envision possibilities beyond the known, guiding them toward new theories and experimental designs. It propels them into uncharted territories where conventional thinking is no longer sufficient. Take, for instance, the perplexing case of dark matter. Though it cannot be observed directly, scientists have deduced its existence through its gravitational effects on visible matter. The leap of imagination that allows us to theorize about the unseen, be it exotic particles or modifications to the laws of gravity, has driven decades of research into one of the universe's most profound mysteries. Without the ability to think beyond the known, we would have never advanced our understanding to where it stands today. Imagination also sparks the development of experimental techniques that allow scientists to explore anomalies. When faced with strange phenomena like unusual radiation patterns from distant galaxies, it is imaginative thinking that drives scientists to create new instruments or methods for further investigation. This creativity doesn't just expand the scientific toolkit, it fosters deeper, more nuanced explorations of reality itself. Imagination thus enables a constant reimagining of what is possible, breaking barriers and creating new opportunities for discovery. Furthermore, imagination fosters collaboration across disciplines. In the search for answers to some of the universe's most profound questions, scientists from different fields often come together, bringing diverse perspectives and expertise. This cross-pollination of ideas leads to breakthroughs that would be impossible within the constraints of any one field. Through the interplay of imagination and scientific rigor, society continues to push the boundaries of knowledge, inching closer to unraveling the many mysteries the universe holds. The exploration of cosmic mysteries has far-reaching implications beyond the realm of pure science. It has the power to reshape the educational landscape for future generations. As we unlock the secrets of the universe, we not only deepen our understanding of the cosmos, but also create a compelling narrative that captivates the imagination of young learners. This excitement can invigorate the educational system, encouraging an approach to learning that emphasizes inquiry-based exploration. Students are no longer passive recipients of facts, but active participants in the quest for knowledge. As questions about black holes, dark matter, and the origins of the universe can continue to unfold, they present educators with a wealth of new material to inspire and challenge their students. These cosmic inquiries can enrich curricula in fields ranging from physical science and astronomy to philosophy and ethics. Students are introduced to science as a dynamic and ever-evolving field of exploration, not merely a collection of static facts. They learn that scientific inquiry is intertwined with creativity, logic, and critical thinking, and that the universe itself is a vast, open-ended question to be explored. By engaging with the latest discoveries, students gain first-hand insight into the relevance of science in answering the deepest questions of existence. This fosters a deeper appreciation for the scientific method, encouraging a new generation to continue the pursuit of knowledge and understanding. Through this integration of science and creativity, we not only inspire curiosity, but also build a more informed, inquisitive society, ready to face the mysteries of the cosmos, with wonder, humility, and a thirst for discovery. As technology continues to evolve at an unprecedented pace, the opportunities for exploring the vast mysteries of the cosmos become more and more accessible. Tools such as virtual reality experiences, interactive simulations, and state-of-the-art telescopes allow students from all walks of life to engage directly with the groundbreaking findings of modern astrophysics. These advancements democratize access to the universe's secrets, breaking down barriers that once limited scientific exploration to a select few. With such accessibility, the scientific community is set to become increasingly diverse, as students from a wide range of backgrounds bring fresh perspectives, new ideas, and innovative solutions to the table. This cultural infusion enhances creativity within the scientific world, making discoveries not only more profound, but also more inclusive and varied. The impact of these tools, however, goes beyond mere academic engagement. They spark an early curiosity about the universe. Such curiosity is not limited to science alone. It shapes broader values, fostering wonder and humility in those who venture into these cosmic realms. Young minds are encouraged to think critically about humanity's role within the grand expanse of space, pushing them to question the deeper meanings of existence and our place in the universe. As education increasingly integrates the excitement of cosmic exploration into the curriculum, future generations will not only be equipped to become adept scientists and researchers, but will also grow into thoughtful, engaged global citizens. These individuals will be more attuned to the interconnectedness of all knowledge and understand the subtle relationships that bind humanity to the larger cosmos. Cosmic anomalies, such as the enigmatic black holes or the elusive dark matter, often evoke a deep sense of awe and wonder in those who encounter them. These celestial mysteries stir something primal within us, an awareness of our own smallness in the face of such vastness. But rather than diminishing our sense of purpose, this realization can inspire an even greater thirst for knowledge. The universe, in all its vastness and complexity, becomes a puzzle, pushing us to seek out answers and understand more about the natural world and our own lives within it. The contemplation of these phenomena is, in many ways, an invitation to explore not just the cosmos, but also ourselves. On a societal level, the study of the cosmos has the potential to unite diverse communities around common goals of scientific discovery. Shared endeavors, such as space missions or community astronomy clubs, provide platforms where individuals from different backgrounds come together, united by a common fascination with the universe. This collaborative spirit fosters a sense of belonging as people engage in meaningful dialogue and exchange of ideas. The diversity of thought that emerges from these shared explorations enriches the field of astrophysics and enhances our collective understanding of the cosmos, furthering cultural appreciation and exchange. However, it is important to acknowledge that the pursuit of cosmic knowledge is not without its psychological toll. The enormity of the universe and the uncertainty surrounding its nature can sometimes trigger feelings of insignificance or existential disorientation. The vastness of space, both in scale and in the mysteries it holds, can provoke a deep sense of helplessness. For some, the realization that we are but a tiny speck in a seemingly indifferent cosmos may stir existential dread or even a sense of futility. Yet, these uncomfortable emotions often lead to significant moments of reflection, prompting individuals to reevaluate their priorities and values in light of the grand questions posed by the universe. While unsettling, these feelings can ultimately serve as a catalyst for growth, encouraging people to seek meaning beyond their immediate experience and embrace the complexities of existence. As humanity continues its exploration of space, the psychological effects of these revelations will evolve in tandem with new discoveries. Some of these findings may be unsettling, but they also have the potential to reshape our understanding of reality. Each new discovery, while often challenging our preconceived notions, may also provide new insights that help us redefine our place in the world and in the universe. Engaging with the cosmos can be a deeply transformative experience, stretching the boundaries of human thought and sparking a profound shift in how we view ourselves and our world. Venturing into the unknown brings with it a profound emotional resonance, as it challenges our conceptions of reality and our place within it. When we explore the far reaches of space, or even the microscopic world, we are often struck by a sense of awe, an awe that arises from encountering phenomena that push the limits of our understanding. This sense of wonder is not merely an intellectual reaction, it is deeply emotional, touching on something primal within us. The mysteries we uncover compel us to reflect on our own existence, prompting profound philosophical questions about our purpose and the nature of life itself. In many ways, the exploration of the cosmos acts as a bridge between scientific inquiry and the human experience. For many, the quest to uncover the truths of the universe creates a sense of connection to something greater than themselves. It serves as a spiritual journey, one that complements our pursuit of meaning in life. As we search for answers in the stars, we also search for meaning in our own lives, leading to a more profound appreciation for both our fragility and our resilience in the face of a vast and ever-expanding universe. Through this exploration, we begin to see ourselves not as isolated beings, but as part of a much larger narrative, bound to the cosmos in ways we are only beginning to understand. Navigating the unknown is an inherently human endeavor, one that often brings a deep sense of uncertainty and vulnerability. This duality serves as a poignant reminder of the limits of our understanding of the vast cosmos and the intricate design that governs it. Embracing the mysteries that surround us fosters humility, for in our quest for knowledge, we are constantly reminded that there are realms far beyond our current grasp. The emotional impact of exploring the unknown extends beyond the individual, uniting entire communities and cultures. Through shared moments of discovery, we collectively build a sense of wonder, linking us to one another in ways that transcend borders and backgrounds. As we gather knowledge about the universe, we do more than just enhance our scientific literacy. We nurture a spirit of curiosity, exploration, and interconnectedness that binds us as a global community. This process of inquiry, fueled by our mutual fascination with the cosmos, enriches both our personal and collective understanding of existence, weaving a complex tapestry threaded with curiosity, humility, and unity. In this journey, it is not only the discoveries themselves that are vital, but also the stories behind them, stories that humanize science and remind us of the incredible resilience and passion required to uncover the secrets of the universe. Personal narratives of scientists play an essential role in shaping the way we understand the cosmos. When scientists share their individual experiences, they provide a window into the heart of their work, showing us not only their discoveries, but also the personal motivations and challenges that have driven them. These stories often reveal the serendipity of great breakthroughs, the years of painstaking effort that precede them, and the inevitable doubts that all great minds face along the way. By unveiling these journeys filled with triumphs, setbacks, and the relentless pursuit of knowledge, scientists breathe life into their work, reminding us that science is not a sterile collection of facts, but a living, evolving endeavor. Each scientist walks a unique path, shaped by their background, their interests, and the discipline through which they approach the universe. Some come from fields steeped in astronomy, while others might approach cosmic questions from diverse perspectives, such as physics, chemistry, or engineering. These varying vantage points often lead to groundbreaking theories, offering fresh insights into the mysteries of the universe. For instance, the stories of collaboration between fields like physics and chemistry or mathematics and engineering illuminate the interdisciplinary nature of scientific discovery. By sharing these connections, scientists offer us a broader understanding of how knowledge is built, piece by piece, often in collaboration with others, and the teamwork that drives major scientific advances. Moreover, personal narratives have the power to inspire future generations of scientists. Hearing about the struggles and successes of established researchers provides young minds with both encouragement and insight into the nature of scientific inquiry. These stories show aspiring scientists that exploration requires resilience, often demanding a willingness to fail and learn from those failures. This knowledge is invaluable as it fosters a rich, supportive community of thinkers eager to tackle the cosmic mysteries that remain just beyond our reach. As the next generation steps forward, these narratives encourage them to dream big and pursue their own paths in science. The sharing of personal stories does more than just illuminate the human side of science. It also builds a bridge between the scientific community and the public. By revealing their personal challenges and achievements, scientists foster a dialogue that brings science closer to the public consciousness, sparking curiosity about the universe and inspiring interest in scientific exploration. These stories highlight that the pursuit of cosmic knowledge is not confined to the labs or observatories. It is a shared journey that transcends disciplines, backgrounds, and borders. Throughout history, unexplained phenomena have often served as catalysts for some of the most groundbreaking discoveries in science. Take, for example, the strange movements of planets in the night sky, which puzzled ancient astronomers for centuries. The wandering paths of Mars, in particular, posed a significant challenge and prompted the development of increasingly sophisticated models of celestial mechanics. These challenges eventually led Johannes Kepler to formulate his laws of planetary motion in the early 17th century, forever changing our understanding of orbits and gravitational forces. In a similar vein, the study of electricity and magnetism in the 19th century saw researchers grappling with unexplained relationships between electric currents and magnetic fields. This puzzle sparked the curiosity of pioneering scientists like Michael Faraday and James Clerk Maxwell, who delved deeper into these phenomena. Their investigations not only illuminated the nature of electromagnetic waves, but also laid the foundation for understanding electricity and magnetism as intertwined forces, ultimately revolutionizing technology and communications. In the field of medicine, unexplained outbreaks of diseases have also driven scientific inquiry. The cholera outbreaks of the 19th century, particularly in London, confounded health officials, prompting an investigation into the source of the epidemic. This inquiry ultimately led to the groundbreaking work of John Snow, who mapped the incidence of cholera and identified contaminated water as the source. Snow's work laid the foundations for modern epidemiology, proving that careful observation and analysis of unexplained phenomena could lead to life-saving breakthroughs. Similarly, the early 20th century brought with it the mystery of radioactivity. The unexpected emissions from uranium and radium sparked curiosity in the scientific community and led to intense investigations into atomic structure and the nature of radioactivity itself. Pioneers like Marie Curie advanced our understanding of these phenomena, making significant contributions not only to the field of chemistry and physics, but also to medicine and energy. Their discoveries have had lasting impacts, influencing treatments for various diseases and shaping the future of energy solutions. The history of unexplained phenomena shows that time and again, the pursuit of understanding the unknown has led to profound advancements in human knowledge. Each of these mysteries, whether planetary motion, electromagnetic interactions, disease outbreaks, or radioactivity, has acted as a beacon, guiding scientific inquiry and reshaping our understanding of the world around us. At the intersection of science and philosophy lies a rich landscape for exploring cosmic anomalies. These mysterious phenomena, black holes, dark matter, cosmic microwave background radiation, pose fundamental questions that challenge the very nature of our reality. When confronted with such enigmas, scientists often find themselves at a crossroads, where the empirical methods of science intersect with the abstract reasoning of philosophy. This intersection sparks deep philosophical discussions about the nature of existence itself. Philosophy encourages us to question the very assumptions that underpin our scientific theories. For example, the existence of black holes raises questions not only about the nature of space and time, but also about causality itself. If something falls into a black hole, never to escape, what does that mean for our understanding of the universe's fate? Such questions transcend the confines of physics, delving into existential debates about free will, determinism, and the ultimate nature of reality. On the other hand, science provides the empirical data and methodologies necessary to investigate and validate these cosmic anomalies. Observations of gravitational waves, for instance, have not only confirmed Einstein's predictions about general relativity, but have also prompted questions about the very structure of the universe. The relationship between science and philosophy, then, is a reciprocal one. Scientific discoveries fuel philosophical inquiry, while philosophical reflections shape the direction of scientific exploration. Together, science and philosophy encourage a holistic approach to understanding cosmic anomalies, pushing us to consider not just the empirical evidence, but also the ethical and existential implications of our findings. This integrated perspective enriches our understanding, transforming the study of cosmic mysteries into a quest to uncover deeper truths about existence itself. As technology advances, so too does our ability to explore the cosmos. One of the most exciting developments on the horizon is the next generation of space telescopes, most notably the James Webb Space Telescope. With its mission to observe distant galaxies and cosmic anomalies, the Webb telescope promises to revolutionize our understanding of the universe. By peering into the infrared spectrum, it will provide a glimpse into the early universe, detect exoplanets, and analyze their atmospheres for signs of life. This breakthrough will expand our perception of where life might exist beyond Earth, opening up new avenues of discovery and exploration. In the coming years, as we continue to gaze into the cosmos, the unknown will undoubtedly remain a source of wonder, challenge, and inspiration. Yet, it is this very unknown, along with the collective pursuit of knowledge, that fuels our quest to understand the universe and our place within it. Advancements in quantum computing present extraordinary possibilities, particularly when applied to the complex realm of astronomical data processing. Traditional methods of analyzing vast quantities of information from telescopes are often painstakingly slow and less efficient. In contrast, quantum computers possess the remarkable capability to tackle astrophysical equations at unprecedented speeds. This leap in computational power could revolutionize our ability to conduct real-time simulations of celestial phenomena, events like supernovae explosions or black hole mergers. Such simulations, which would take conventional computers years to process, could unfold in mere moments with the power of quantum computing. This acceleration in processing could unlock groundbreaking discoveries in far less time than previously imaginable. Another promising frontier lies in the detection of gravitational waves, ripples in space-time caused by massive cosmic events such as colliding black holes or neutron star mergers. With cutting-edge facilities like the Laser Interferometer Gravitational Wave Observatory, LIGO, scientists have begun to capture these subtle distortions in the fabric of space-time, offering an entirely new way of observing the universe. These ripples, undetectable by traditional telescopes that rely on electromagnetic waves, provide us with a form of cosmic hearing. Through this groundbreaking approach, we can study cosmic events that were once hidden from our view, providing insight into the most violent and enigmatic phenomena in the universe. As gravitational wave detectors continue to evolve, they could dramatically expand our understanding of the cosmos and offer a fresh perspective on the universe's most extreme and mysterious occurrences. Furthermore, artificial intelligence, AI, is emerging as a transformative tool in astronomy, significantly enhancing the speed and precision with which researchers process data. Machine learning algorithms can sift through enormous data sets far more efficiently than humans, identifying patterns and anomalies that would otherwise go unnoticed. In particular, these AI systems are proving invaluable in the detection of transient astronomical events like supernovae or gamma-ray bursts. By automating the identification process, these algorithms free up scientists to focus their attention on the most important discoveries. As technology advances, AI and machine learning will continue to play a pivotal role in unraveling the universe's mysteries, offering scientists the tools they need to make breakthrough discoveries in record time. Looking toward the future, space missions will likely integrate a combination of advanced technologies and innovative methodologies to explore the universe's many unexplained phenomena. One of the most promising developments is the deployment of next-generation telescopes, equipped with enhanced imaging capabilities and broader spectral ranges. These state-of-the-art instruments will vastly improve our ability to detect faint signals and light from distant cosmic events. This will be crucial in the search for elusive phenomena like dark matter, dark exoplanets that might harbor life. With these advanced telescopes, scientists will gain access to data that was once out of reach, enabling them to make more accurate observations and refine their theories about the universe's most enigmatic elements. In addition to upgraded telescopes, future space missions may rely on collaborative networks of satellites and probes working together as a synchronized system. This approach would allow for comprehensive data collection across multiple platforms, enabling researchers to analyze cosmic events in real time. By sharing information across a network of interconnected instruments, scientists can piece together a fuller understanding of these phenomena, much like a team of detectives working in unison to solve a complex case. This cooperative strategy will be instrumental in revealing deeper truths about the universe's nature and structure. As these technologies evolve, artificial intelligence will be an indispensable part of these missions, playing a crucial role in analyzing and interpreting the enormous volumes of data they generate. As technology advances, space missions are also expected to venture into previously uncharted territories, exploring environments once considered inaccessible. These might include the interiors of gas giants or the farthest reaches of interstellar space. New probes, designed to withstand extreme conditions, will offer us an unprecedented opportunity to study these harsh and enigmatic regions of the universe. These explorations could provide vital clues that help us unlock the mysteries of gravity, time, and the very fabric of reality itself. Such missions hold the potential to answer some of the most profound questions humanity has ever asked about the cosmos. However, developing new theories to explain cosmic anomalies presents a unique set of challenges. One of the biggest hurdles scientists face is the sheer scale and complexity of the universe. Phenomena like dark matter or the accelerating expansion of the universe defy existing scientific frameworks, often leading to long periods of uncertainty. Researchers are left grappling with how to reconcile these new observations with established theories, which may no longer apply to the full breadth of cosmic phenomena. The vast distances and extreme conditions of outer space make direct experimentation nearly impossible, forcing scientists to rely on indirect measurements and simulations to hypothesize explanations. Another significant challenge arises from the interdisciplinary nature of cosmology. The vastness of the universe requires input from a variety of scientific disciplines, including physics, astronomy, and mathematics. This can create fragmentation in understanding, as experts in one field may not always be able to communicate effectively with those in another. For example, complex mathematical theories may be difficult for those without a strong background in the subject to grasp, potentially stalling collaborative efforts. This underscores the importance of interdisciplinary approaches, where open communication and shared insights from multiple fields can lead to more comprehensive and unified theories. To overcome these challenges, scientists have increasingly turned to advanced technologies and innovative methodologies. High-powered telescopes, along with sophisticated simulations, allow researchers to gather more data than ever before. This, in turn, enables them to refine their models and adapt to new discoveries. The use of artificial intelligence and machine learning has also proven to be a game changer, helping astronomers process and analyze vast data sets with an efficiency that was previously unimaginable. These advancements are reshaping the field of astronomy and paving the way for deeper insights into the universe's most perplexing mysteries. As we look toward the future, the integration of these groundbreaking technologies promises to accelerate our exploration of the cosmos and unlock secrets that have remained hidden for centuries. With the power of quantum computing, AI, and collaborative space missions, we stand on the cusp of a new era in astronomy, one where the mysteries of the universe may soon be within our grasp. International collaboration has become a cornerstone of scientific advancement, particularly in the study of cosmic anomalies. As the mysteries of the universe often stretch beyond the limits of national borders, global partnerships have enabled researchers to pool their resources, expertise, and technologies. Through these collaborations, scientists from all corners of the world are uniting their strengths in the quest to understand some of the most profound phenomena in the cosmos. This pursuit of knowledge is not without its challenges. The journey to unravel the mysteries of space is one marked by persistence and adaptability. As scientists refine their theories, they must remain open to new ideas, especially those that challenge conventional thinking. It is this willingness to question assumptions and to embrace uncertainty that drives scientific progress forward. The process of testing hypotheses, failing, and refining them is an iterative cycle that defines the evolution of our understanding of the universe. Each new discovery, no matter how small, brings humanity one step closer to explaining the unknown. The role of international cooperation cannot be overstated. The vastness and complexity of the universe present challenges that no single nation could tackle alone. By joining forces, countries can maximize their collective resources and tap into a diverse pool of ideas and perspectives. This collaborative spirit leads to innovative solutions to problems that may otherwise remain unsolved. Projects that span multiple countries and agencies are often the ones that break new ground and push the boundaries of scientific discovery. One of the most striking examples of international collaboration is the International Space Station, ISS. This remarkable laboratory orbiting the Earth is the product of cooperation between space agencies like NASA, the European Space Agency, Russia's Roscosmos, and others. Scientists and astronauts from these organizations work side by side in a shared environment, conducting experiments that provide invaluable insights into everything from the behavior of materials in microgravity to the impact of extended space missions on human health. These findings not only enhance our understanding of space, but also translate into tangible benefits on Earth, QB, such as advancements in medicine and technology. Another prime example of global collaboration is the Event Horizon Telescope, EHT. This project, which seeks to capture images of black holes, relies on a network of radio telescopes scattered across the globe. By linking these telescopes together, researchers have been able to observe phenomena that were once thought to be beyond our reach. The images of black holes that the EHT team has captured mark a groundbreaking achievement in astrophysics. They showcase the power of shared infrastructure and unified goals, proving that when scientists from different nations come together, they can achieve the seemingly impossible. Through these international efforts, scientists gain access to a broader range of data and insights, enabling them to analyze cosmic phenomena on a much larger scale. As they work together, they refine their conclusions, adding greater depth and nuance to our understanding of the universe. These collaborations not only advance scientific knowledge, but also foster a sense of global solidarity. They remind us that the pursuit of knowledge is not constrained by political, cultural, or geographical differences. When nations unite in the search for truth, they create a shared mission that transcends borders and divisions. The impact of international cooperation extends beyond the academic sphere. It serves as a powerful reminder that the quest for understanding the cosmos is a deeply human endeavor. As countries come together to explore the secrets of black holes, gravitational waves, and dark matter, they spark a sense of curiosity and wonder that resonates with people across the globe. This collective journey inspires future generations of scientists as well as everyday citizens to engage with the mysteries of the universe. It encourages a sense of global citizenship rooted in the shared goal of discovery. In recent years, the landscape of space exploration has been further transformed by private space enterprises. Companies like SpaceX, Blue Origin, and others are challenging the traditional boundaries of space exploration by developing advanced technologies and pushing the frontiers of what is possible. These companies are not merely launching rockets, they are revolutionizing our understanding of the cosmos by providing new avenues for research and exploration. Their ability to develop and deploy cutting-edge technologies quickly has opened up new opportunities for scientific inquiry, particularly in areas like dark matter, extraterrestrial life, and the origins of the universe. Private enterprises are also transforming the economic landscape of space exploration. By providing cost-effective launch solutions, they enable a greater number of missions to be conducted, many of which focus on investigating the universe's most enigmatic phenomena. Their innovation has democratized access to space, allowing a broader array of research institutions and universities to participate in the exploration of the unknown. This increased accessibility means that more scientists from diverse backgrounds and fields of study can contribute to solving some of the universe's most enduring mysteries. Moreover, private space companies are increasingly collaborating with academic and governmental research initiatives. These partnerships combine the strengths of both sectors, the agility and innovation of the private companies with the rigorous methodologies and long-term perspectives of academic institutions. Initiatives like the Planetary Society's Light Sail project, focused on solar sailing, highlight how public-private partnerships can push the boundaries of space exploration. Such collaborations may one day provide the technological foundation for missions beyond our solar system. As private companies continue to grow, their contributions to space exploration are expected to evolve. They will play a pivotal role in deep space exploration, uncovering new insights into our own planet as well as the broader universe. Their influence is already being felt in fields such as gravitational wave research and the study of cosmic background radiation. The creativity, competitiveness, and entrepreneurial spirit of the private sector provide a fertile ground for breakthroughs that could illuminate the unknown. In addition to these institutional collaborations, citizen science initiatives are also making significant strides in the exploration of cosmic anomalies. These programs invite everyday people from all walks of life to join professional scientists in collecting, analyzing, and sharing data about the universe. Citizen science projects enable ordinary individuals to contribute to scientific discoveries that would otherwise be overlooked or misunderstood. One notable example of citizen science is the Galaxy Zoo project, which enlists volunteers to classify millions of galaxy images. By participating in this project, volunteers help researchers better understand the structure and morphology of galaxies, including unusual formations that may warrant further investigation. This collaborative model accelerates the pace of discovery by tapping into the collective power of thousands of participants. The sheer volume of data processed by citizen scientists far exceeds what a small team of researchers could handle, thereby expanding the scope of cosmological research. These citizen science programs also play an important role in the detection of transient astronomical events, such as supernovae, gamma-ray bursts, and gravitational waves. With the help of a global network of amateur astronomers and volunteers, scientists can identify these elusive phenomena, which often last only for brief moments in time. The data gathered through such initiatives is invaluable, providing critical insights into the nature of the universe and the forces that govern it. In sum, the exploration of cosmic anomalies is a collaborative, global effort that involves the combined efforts of scientists, private companies, and ordinary citizens. Through international partnerships, private sector innovation, and citizen engagement, humanity is pushing the boundaries of what is known, inching ever closer to understanding the vast mysteries of the cosmos. The pursuit of knowledge continues to unite us all, sparking curiosity and inspiring future generations to look up to the stars. The vast expanse of our universe is an endless source of wonder and mystery, with each new discovery unveiling more questions than answers. Among the most exciting initiatives driving our understanding of the cosmos is the Planet Hunters Project, which invites citizen scientists to play an active role in the search for planets beyond our solar system. By analyzing light curves captured by space telescopes, these volunteers contribute to the identification of exoplanets that defy conventional understanding, planets whose orbits, characteristics, or behaviors challenge our established theories of planetary formation and dynamics. Every new exoplanet discovery enriches our knowledge of the universe, providing insights that refine and expand existing models of the cosmos. But the importance of these efforts goes beyond the acquisition of knowledge. They also foster a powerful sense of community. Citizen scientists, working alongside professional astronomers, not only contribute to our collective scientific understanding, but also develop a deeper connection to the universe itself. As they engage with complex data and make meaningful contributions to major discoveries, these volunteers gain a unique appreciation for the intricacies of the cosmos. This collaboration between professionals and amateurs highlights the democratization of science, showing that the quest for knowledge is not restricted to experts, but is an open frontier for anyone with the curiosity to explore. In a world where curiosity and exploration can be sparked by anyone, regardless of background or experience, these collaborative efforts inspire many to pursue careers in science, technology, engineering, and mathematics. They help break down the walls that have traditionally separated the world of academic research from the general public, reinforcing the idea that science is a communal endeavor, a field in which each person has the potential to contribute to the understanding of the universe. As our technological capabilities advance, our ability to probe the mysteries of the universe has expanded exponentially. Today, we are on the cusp of potentially groundbreaking discoveries that promise to reshape our understanding of reality itself. Dark matter and dark energy, for example, are two of the most mysterious components of the universe. Despite making up a vast majority of the cosmos, they remain largely invisible and elusive, their properties still unknown. Yet, thanks to innovations in observational techniques and an increasing sensitivity to minute cosmic signals, scientists are confident that breakthroughs are imminent. In the near future, we may begin to uncover the true nature of dark matter and dark energy, learning how these invisible forces influence the structure and behavior of the universe. Beyond the realms of dark matter and energy, another area of growing interest is the study of unidentified aerial phenomena, UAP, often referred to as unidentified flying objects, UFOs. In recent years, the frequency of reports and the development of cutting-edge sensor technology have fueled speculation that we may be on the verge of discovering tangible evidence of these strange occurrences. Whether they are related to atmospheric phenomena, advanced human technologies, or potentially extraterrestrial life, the investigation of UAPs is gaining momentum. Both military and civilian studies are poised to offer new insights into this mysterious subject, which could dramatically alter our understanding of the Earth's skies and the possibility of life beyond our planet. In parallel, the field of quantum mechanics continues to intrigue scientists with its strange and counterintuitive principles. Phenomena like quantum entanglement and superposition challenge our fundamental understanding of reality. As physicists push the boundaries of quantum experiments, we are likely to witness breakthroughs that could reveal deep insights into the nature of space, time, and matter itself. One particularly exciting frontier is the intersection of quantum mechanics and consciousness, a domain that could, in the near future, offer radical new perspectives on how human consciousness interacts with the physical world. These explorations might not only transform physics, but could also provide profound implications for our understanding of the human experience. As researchers continue to push the limits of knowledge, the importance of interdisciplinary collaboration becomes more apparent. Complex questions involving dark matter, quantum mechanics, or the study of UAPs cannot be answered in isolation. By drawing from diverse fields such as astrophysics, psychology, and even philosophy, scientists are better equipped to tackle the puzzles that currently elude us. These collaborations could be the key to unveiling the hidden truths of the universe, unlocking new chapters in our understanding of existence. The potential for discovery is limitless, and the years ahead promise to be a thrilling journey into the unknown. With each new revelation, our conception of the universe will be challenged and refined. Some of the most significant advances in scientific discovery are yet to come, and they could reshape our understanding of everything from the origin of the universe to the fundamental nature of life itself. At the heart of these advancements is the rapid evolution of artificial intelligence, AI. the role of AI in exploring the cosmos cannot be overstated, as its ability to process and analyze vast amounts of data far exceeds human capabilities. Every day, space telescopes collect an overwhelming amount of data, from images to spectral readings, which is essential for uncovering cosmic phenomena. However, sifting through this data to identify meaningful patterns and anomalies is a Herculean task for human researchers. This is where AI comes in. By training AI systems to recognize specific features in astronomical data, scientists are able to uncover rare events such as supernovae or gravitational waves with greater efficiency. AI can learn from previous discoveries, refining its algorithms and improving its ability to predict where future phenomena might be found. As the technology advances, these AI systems will become increasingly adept at detecting subtle patterns that human researchers might miss, and in doing so, they will expand our understanding of the cosmos in ways we never thought possible. One of the most exciting aspects of AI is its potential to enhance our understanding of complex cosmological models. AI-powered simulations can explore multiple scenarios simultaneously, taking into account a vast array of variables. This ability to model the universe with greater precision could lead to new insights into the origins and evolution of the cosmos. Furthermore, machine learning, a subset of AI, holds the potential to connect seemingly unrelated events, such as the behavior of black holes, the formation of galaxies, and the influence of dark matter. By linking these phenomena together, scientists can develop a more holistic understanding of how the universe functions and the interconnectedness of its many components. In the coming years, as AI continues to advance, we may find that our grasp of the universe becomes ever more refined, offering answers to questions that have long eluded humanity. What seemed like insurmountable challenges just a decade ago may soon be solved, and the future of space exploration looks more promising than ever before. The path to discovery is wide open, and every new piece of the puzzle we uncover brings us one step closer to understanding the vast and mysterious universe that surrounds us. Artificial intelligence is rapidly emerging as a powerful tool in the search for extraterrestrial life, offering unprecedented capabilities to analyze signals from deep space with far greater precision and speed. With AI's ability to process vast amounts of data, it can help distinguish between natural cosmic phenomena, such as the constant hum of distant stars, and potential signals originating from intelligent extraterrestrial sources. This ability accelerates the quest to uncover evidence of life beyond Earth, moving us closer to answering one of humanity's most profound questions. Are we alone in the universe? The potential for AI to uncover new strategies and insights in this area opens up an exciting new dimension for cosmic exploration. It suggests that artificial intelligence could play a pivotal role in solving long-standing mysteries about the universe and its origins. As these technologies evolve, they promise to enhance our ability to detect patterns that would otherwise be impossible to identify with human capabilities alone, accelerating the search for intelligent life among the stars. At the same time, the complexity of the universe demands an interdisciplinary approach to exploration, one that integrates diverse fields of knowledge and expertise. To truly understand and navigate the vastness of space, we need more than just scientists with expertise in a single domain. This is why interdisciplinary collaboration has become the cornerstone of advancing our cosmic exploration efforts. No single field of study holds the answers to the challenges posed by celestial phenomena. Instead, tackling these questions requires a blend of expertise from various disciplines, ranging from astronomy and physics to engineering, biology, and even social sciences. Only through the combined efforts of researchers from these diverse fields can we begin to address the myriad of obstacles that await us in space. Take, for example, the ambitious goal of sending humans to Mars. This monumental undertaking goes far beyond the realm of rocket science and propulsion technology. It involves biologists who must understand the effects of prolonged space travel on the human body, engineers who need to develop life support systems capable of sustaining astronauts in the harsh Martian environment, and psychologists who must find ways to help astronauts maintain their mental well-being over long periods of isolation. The integration of these various disciplines enables us to address both the practical and psychological challenges of space exploration, offering a more holistic approach to this daunting endeavor. Such collaborative efforts have already led to groundbreaking advancements. For instance, algorithms originally designed to process telecommunications signals are now being adapted to interpret data from distant galaxies. This cross-disciplinary exchange of knowledge accelerates discoveries and fosters an environment where innovation can thrive. When scientists and engineers from different fields come together, they can solve problems that would be insurmountable if tackled alone, unlocking new solutions that drive the frontier of space exploration forward. Astrobiology, an interdisciplinary field in itself, exemplifies how combining knowledge from genetics, chemistry, and the study of extreme environments can shed light on the nature of life beyond Earth. By drawing on expertise from various scientific domains, astrobiologists are creating new models for what extraterrestrial life could look like, vastly expanding our understanding of the potential for life in the cosmos. As our exploration of the universe continues to evolve, fostering a culture of interdisciplinary teamwork will be crucial in unlocking new insights and expanding the boundaries of human knowledge about the cosmos. However, as we advance in our exploration of cosmic anomalies, it is equally essential to ensure that our pursuit of knowledge remains ethically grounded. The mysteries of the universe hold great promise, but we must carefully consider the impact of our discoveries on humanity, society, and the environment. The ethics of scientific exploration must be built on a foundation of responsible research practices, one that prioritizes the well-being of all living beings and the ecosystems that sustain them. This commitment to ethical exploration also requires that we engage with diverse perspectives. Scientists, ethicists, philosophers, and community leaders must come together to ensure that our discoveries do not come at the expense of the greater good. Involving individuals from different fields and backgrounds helps create a more holistic approach to cosmic exploration, one that takes into account the potential social, environmental, and ethical consequences of our actions. For instance, as we develop new technologies to observe distant galaxies or investigate phenomena like black holes, it is essential to evaluate how these innovations might impact local communities, global governance, and the treatment of individuals involved in the research process. Transparency is a key component of this ethical framework. Open communication about the intentions, methods, and findings of scientific inquiry fosters trust among the scientific community and the public. When knowledge is shared openly, it allows for informed discussions about the potential risks and benefits of new technologies and discoveries. This transparency is crucial in mitigating fears and misconceptions about scientific advancements, especially when they have the potential to disrupt established paradigms or societal norms. Furthermore, a continued focus on education is necessary to ensure that future generations of scientists and researchers are imbued with a strong ethical foundation. By teaching aspiring scientists about the moral implications of their work, we can encourage them to think critically about the consequences of their discoveries and the broader impact they may have on humanity. Upholding ethical standards across the scientific community not only protects the integrity of the research, but also ensures that our explorations are rooted in a sense of moral responsibility and purpose. Cultural beliefs and myths about space have long shaped the way societies view unexplained cosmic phenomena. For centuries, different cultures have crafted stories and explanations for celestial events, often attributing them to divine or supernatural forces. These interpretations have influenced the way people perceive and react to unusual phenomena in the sky, blending awe with fear. In ancient times, comets were often seen as omens, affecting how people responded to their appearances. In modern scientific contexts, some researchers acknowledge that cultural narratives can shape their approach to studying phenomena like unidentified flying objects, UFOs, or other unexplained cosmic events. The influence of cultural myths and stories can be both beneficial and problematic. On one hand, such narratives can spark curiosity and inspire further investigation into unknown phenomena. On the other hand, they can also limit scientific inquiry by anchoring researchers in a particular worldview or paradigm. If scientists are deeply rooted in cultural myths, they may overlook alternative explanations or dismiss certain anomalies that do not fit within established frameworks. These cultural narratives can either motivate researchers to explore intriguing hypotheses or, conversely, prevent them from pursuing lines of inquiry that challenge traditional beliefs. In the end, the way we interpret and investigate cosmic anomalies is shaped by a delicate balance between scientific inquiry and the cultural lenses through which we view the universe. As our exploration of the cosmos continues to expand, it is vital that we remain open to new ideas and perspectives, while also critically examining the cultural influences that may shape our understanding of the unknown. Only through this balanced approach can we hope to uncover the true nature of the universe and our place within it. When public interest and funding for scientific research are influenced by cultural narratives, the impact can be profound. These narratives, often shaped by myths about aliens or cosmic events, have the potential to capture the collective imagination of the public, driving research initiatives and sparking funding opportunities that might not arise otherwise. The intertwining of belief systems and empirical inquiry creates a fascinating dynamic where cultural stories, sometimes based more on myth than fact, can inadvertently help advance scientific knowledge. This development raises an important question. Can belief-driven curiosity coexist with the rigorous, unbiased approach that science demands? The challenge lies in finding a balance, one where the rich tapestry of cultural stories can inspire scientific inquiry without overshadowing the need for empirical evidence. In this delicate dance, cultural narratives can serve as a source of inspiration, igniting interest in the mysteries of the cosmos, while scientific methods ensure that our understanding remains grounded in observable, testable reality. At the heart of this discussion is the evolving role that media plays in shaping public perceptions of the universe. Documentaries and other media representations are powerful lenses through which the public engages with cosmic mysteries. These visual narratives have the ability to translate complex scientific concepts into relatable, easily digestible content. In doing so, they bring the enigmatic nature of the universe closer to the everyday viewer. Through stunning visuals, expert interviews, and compelling storytelling, documentaries make topics such as the birth of stars, the nature of black holes, and the search for extraterrestrial life accessible to a broad audience. When well-researched, these media productions can serve to enlighten and inspire curiosity, fostering a sense of wonder and respect for the scientific method. They can spark interest in fields like astronomy and astrophysics, encouraging viewers to look up at the stars with renewed fascination. However, there is a dark side to media portrayals that fail to maintain scientific integrity. Sensationalized representations, such as films or TV shows that overdramatize the dangers of space exploration or misrepresent scientific theories, can distort public understanding and breed misconceptions. These portrayals can generate unfounded fears or spread false beliefs about the nature of the cosmos, leaving audiences with an inaccurate view of reality. The balance between entertainment and education is delicate, and it is up to media creators to ensure that their work does not sacrifice accuracy for the sake of intrigue. Upholding scientific integrity while captivating an audience is no easy task, yet when achieved, the rewards are immense. The portrayal of cosmic mysteries in an engaging yet scientifically sound manner helps bridge the gap between the scientific community and the public. Popular programs create shared cultural experiences, sparking conversations about profound questions like humanity's place in the universe and the future of space exploration. These discussions can, in turn, cultivate a more informed citizenry, one that supports science education and advocates for the funding of scientific research. As viewers become more invested in understanding the cosmos, they may feel a greater responsibility to back policies that promote scientific inquiry. In this way, documentaries do more than simply inform. They shape the public's attitudes towards science, influencing everything from school curriculums to government allocations for space exploration. The broader impact of these media portrayals is not limited to the dissemination of knowledge. By demystifying the cosmos and framing it within a compelling narrative, documentaries can inspire entire generations to look up at the stars with awe and wonder. This pursuit of knowledge, driven by curiosity and inquiry, serves as a powerful force for unity. Across the globe, people from diverse backgrounds have been drawn to the night sky, pondering the same fundamental questions about existence, the origins of life, and the very nature of reality. This universal curiosity transcends geographical boundaries, creating a common thread that unites humanity in its search for answers. Scientific endeavors like space exploration and astronomy have long been a source of international cooperation. The International Space Station, for example, serves as a testament to how shared goals can bring together scientists, engineers, and researchers from across the globe. By collaborating, they combine their unique perspectives and expertise, enriching the scientific narrative and fostering mutual understanding. These joint efforts often lead to friendships and cultural exchanges, demonstrating how humanity's collective pursuit of knowledge can bridge cultural divides. Beyond the realm of science, cosmology has deeply influenced art, philosophy, and spirituality. Different societies interpret celestial bodies and cosmic phenomena through their own cultural lenses, leading to rich dialogues about the nature of the universe. For instance, many indigenous cultures view the stars as integral parts of their traditions, linking the cosmos to their spiritual beliefs and storytelling. Engaging with these diverse viewpoints allows us to deepen our understanding of the universe, enriching both scientific inquiry and cultural appreciation. In a world increasingly defined by division, the quest to comprehend the cosmos stands as a beacon of hope. It not only propels scientific progress, but also nurtures solidarity among different cultures. As distinct peoples come together in the shared journey of discovery, they contribute to the creation of a global community united by a common sense of wonder and curiosity. Ultimately, this shared pursuit reminds us that our differences are but threads in a larger, intricate tapestry, one woven together by the universal bonds of inquiry and exploration. In recent years, social media has revolutionized how the public engages with unexplained phenomena in space, transforming isolated curiosity into a widespread global dialogue. Platforms like Twitter, Facebook, and Instagram allow scientists and astronomers to share their discoveries directly with the public. But more importantly, these platforms create spaces for people from all walks of life to discuss, debate, and share their own interpretations of mysterious events. The instant access to information has allowed the general public to participate in conversations that were once reserved for specialists and academics alone. This rapid spread of information through social media has amplified public interest in phenomena such as unidentified flying objects, UFOs, and strange cosmic events. When new discoveries are made, they can quickly trend online, capturing the attention of thousands, if not millions of people. Hashtags related to specific events often lead to widespread discussions, where amateur enthusiasts, experts, and everyday individuals exchange ideas, research articles, and even personal sightings. This democratization of knowledge fosters a community driven by awe and wonder, united in their curiosity about the universe. In this new digital age, the lines between experts and the public have become increasingly blurred. Social media not only allows scientists to reach a broader audience, but also enables ordinary people to engage with the most extraordinary phenomena in ways that were once unimaginable. This collaborative approach to understanding the universe holds great potential for inspiring future generations to continue exploring the mysteries of space, while also nurturing a global community that shares a common sense of wonder about the cosmos. The rise of social media has transformed the way we interact with the world around us. While it opens up new avenues for information and communication, it also presents significant challenges. One of the most pressing concerns is the potential for misinformation to spread like wildfire. With the constant influx of content, it becomes increasingly difficult to separate fact from fiction. Sensational headlines often attract more attention than in-depth research. And in this environment, the line between truth and myth can easily blur. This presents a unique challenge. As users of social media, we must develop critical thinking skills to sift through the vast sea of content, discerning which pieces of information are grounded in fact and which are based on fanciful ideas. Despite the potential downsides, social media has undeniably played a pivotal role in sparking public interest in space and scientific inquiry. The digital landscape has brought the mysteries of the cosmos to the forefront of everyday consciousness, creating a space where both amateur enthusiasts and seasoned experts can share ideas, discoveries, and theories. Social media platforms have empowered a new generation of astronomers, physicists, and curious minds by providing an easy way to connect and exchange knowledge. With a simple click, users can dive into the latest discoveries, interact with scientists, and engage in conversations about the vast, uncharted territories of our universe. The accessibility and engagement fostered by social media have made the wonders of space more tangible and thrilling than ever before. Filmmakers, educators, and content creators have seized this opportunity to make complex scientific topics more relatable to the general public. By weaving compelling visual narratives and using analogies, they can break down intricate concepts into something the average viewer can grasp. For example, instead of launching straight into the esoteric science behind black holes, educators might compare the phenomenon to a whirlpool in water, a concept far more familiar. In this way, abstract ideas are grounded in real-world experiences, making them more accessible and engaging. The role of visuals cannot be overstated in this educational journey. High-quality animations and simulations transform raw data into captivating images of distant galaxies, black holes, and supernovae. Artists and scientists collaborate to bring these cosmic phenomena to life, often using vibrant colors and dynamic animations that are as scientifically accurate as they are aesthetically striking. These visual representations serve not only to captivate, but to simplify the complex mechanics of space, making it easier for viewers to comprehend the vastness, scale, and beauty of our universe. In addition to compelling visuals, storytelling has become an essential tool in making space science more accessible. By framing scientific discoveries within the personal journeys of researchers, filmmakers, and educators provide an emotional context that draws viewers in. The story of a scientist observing a distant galaxy or the excitement of uncovering a new cosmic anomaly resonates on a human level, turning what might otherwise be dry, technical information into something deeply personal and engaging. This emotional connection encourages viewers to invest in the narrative and share in the excitement of the discoveries. Moreover, the interactive nature of social media allows audiences to become active participants in their learning journey. Through live discussions, Q&A sessions, and interactive polls, social media can foster a sense of community and shared exploration. Educators and filmmakers can encourage viewers to reflect on their own understanding of space and challenge their perceptions. This active engagement doesn't just foster curiosity, it empowers people to think critically about the universe's mysteries and inspires them to learn more. At the heart of this educational movement lies the responsibility of scientists to communicate their discoveries effectively. Scientists, in many ways, are not just researchers, they are educators, translators of knowledge who make complex ideas accessible to a broader audience. It is not enough to publish groundbreaking findings in academic journals that remain inaccessible to the general public. The true value of these discoveries lies in their ability to be understood, appreciated, and explored by the wider community. The impact of cosmic anomalies, such as black holes, gravitational waves, and dark matter, extends far beyond the realm of science itself. These phenomena spark deep philosophical questions about the nature of reality and our place in the universe. They can influence societal views on everything from the origins of the cosmos to the potential for future technological advancements. For instance, understanding the mechanics of black holes could lead to breakthroughs in energy production or space travel. Therefore, scientists have a duty not only to share their findings, but to contextualize them within the broader societal and ethical discussions that these discoveries provoke. Ethical communication has become more important than ever. In an age where sensationalism often overshadows truth, scientists must strive to present their discoveries in a way that is honest and transparent. This means addressing the complexities and uncertainties of scientific research, acknowledging the limitations of current understanding, and ensuring that their findings are communicated with nuance. By doing so, scientists can help prevent the spread of misinformation, reduce misconceptions, and promote a more informed public discourse around these fascinating phenomena. In addition to their role as communicators, scientists also serve as stewards of knowledge. Their passion for discovery has the power to inspire the next generation of thinkers and innovators. When scientists share their excitement about the cosmos, they ignite curiosity in young minds, encouraging them to explore careers in science, technology, engineering, and mathematics, STEM. This inspiration is crucial for the future of space exploration and scientific progress. As the next generation of scientists, engineers, and thinkers emerge, they will carry forward the torch of discovery, unraveling the mysteries of the universe. The way we approach space exploration has evolved significantly over the years, shaped by the experiences and perspectives of each generation. The excitement of the Apollo missions, for example, sparked a sense of wonder and possibility, inspiring people to believe in the power of human ingenuity. However, younger generations, growing up in the age of the internet, social media, and rapid technological advancements, often take a more collaborative, data-driven approach to exploration. For them, space exploration is not confined to government agencies, but is seen as a global endeavor, where private companies, citizen scientists, and international collaborations all contribute to the pursuit of knowledge. This shift in perspective has led to new forms of exploration. Citizen scientists, for example, now play a pivotal role in gathering data, contributing to our understanding of celestial phenomena, and providing fresh insights into previously unexplored territories. Crowdsourced efforts and collaborative projects are enhancing our ability to explore the unknown, creating a more diverse and inclusive approach to scientific inquiry. In conclusion, the way we explore, understand, and communicate the mysteries of space is undergoing a profound transformation. Social media, storytelling, and interactive engagement have made space science more accessible and exciting, while the responsibility of scientists to communicate their discoveries clearly and ethically ensures that the public remains informed and engaged. As the next generation of explorers and thinkers emerges, the pursuit of knowledge will continue to inspire, challenge, and ultimately unlock the secrets of the cosmos. Generational differences in attitudes towards space exploration, funding priorities, and public interest further complicate the pursuit of scientific discovery in this field. Older generations often champion large-scale, long-term missions that require substantial financial investments, despite taking years to develop and implement. These missions, however, tend to yield significant, groundbreaking discoveries that reshape our understanding of the cosmos. In contrast, younger generations are more inclined to support agile, tech-driven missions that leverage advanced technologies to gather data swiftly and cost-effectively. This approach often involves exploring unconventional questions that may not align with traditional research frameworks, but which could open up new frontiers in scientific knowledge. The evolving discourse between generations also shapes society's perception of unexplained phenomena. As awareness of global challenges such as climate change, artificial intelligence, and space debris rises, discussions around space exploration are increasingly intertwined with broader concerns. This interplay of urgency and curiosity fosters a holistic worldview, one that links the pursuit of knowledge with the need for sustainability. It pushes humanity toward a future where understanding the unknown is seen as crucial, not only for scientific progress, but also for our survival as a species. Every generation contributes to a growing legacy, building on the accomplishments and lessons of those that came before, as we collectively forge a path toward deeper exploration of the cosmos. Unexpected discoveries in space have a remarkable ability to challenge and sometimes reinforce cultural narratives that shape our understanding of the universe and our place within it. When new celestial phenomena are uncovered, whether it be the discovery of previously unseen planets, the bizarre behavior of distant galaxies, or the detection of organic compounds on other celestial bodies, these findings can either illuminate or contradict long-standing beliefs about humanity's relationship with the cosmos. One of the most transformative discoveries in recent decades has been that of exoplanets, planets that orbit stars beyond our solar system. This revelation has profoundly altered our perception of what is possible in the universe. The idea of life on distant worlds has been a central theme in human mythology and storytelling for centuries. The tangible evidence of exoplanets, especially those located in the habitable zones of their stars, has reignited these ancient narratives, fueling optimism about the existence of extraterrestrial life. For many, the discovery of these planets serves as a beacon of hope, reinforcing cultural narratives about the potential for life beyond Earth and encouraging a sense of unity in the broader cosmic community. On the other hand, certain discoveries have the power to disrupt well-established cultural and philosophical worldviews. The early work of astronomers, which revealed that Earth is not the center of the universe, caused significant tension with long-held beliefs that placed humanity at the focal point of existence. As our understanding of the universe expands, particularly with recent revelations about the vastness of dark matter and dark energy, humanity is forced to confront existential questions about our place in the grand scheme of the cosmos. These scientific advances invite us to reassess our significance, not just in relation to the universe, but also in terms of the larger questions surrounding the origins and future of life. Furthermore, unexpected discoveries often spark collective curiosity and imagination, inviting diverse cultural interpretations. As new scientific revelations unfold, societies across the globe adopt varying narratives in an attempt to make sense of their origins, destinies, and the nature of the universe. The story of space exploration is not a static one. It evolves continuously, intertwined with human culture, sometimes challenging our perceptions and sometimes reinforcing them. But no matter the outcome, it always propels us to ask deeper, more profound questions about the mysteries that lie beyond our reach. The portrayal of space exploration in popular culture plays a crucial role in shaping public perceptions and stoking public interest in scientific endeavors. Movies, television shows, and books often dramatize the pursuit of knowledge, presenting scientists as heroic figures embarking on grand adventures. These narratives can ignite a sense of awe and wonder, inspiring younger generations to pursue careers in science, technology, engineering, and mathematics, fields collectively known as STEM. When space exploration is depicted as an exciting and dynamic frontier, it draws attention and investment from various sectors, including educational institutions, private companies, and government agencies. Moreover, popular culture often serves as a catalyst for scientific discourse. A blockbuster film that imagines the intricacies of interstellar travel or the mysteries of black holes can spark widespread public curiosity, leading people to engage in discussions about astrophysics, planetary science, and the technicalities of spacecraft design. This increased awareness can, in turn, generate greater public support for space missions, as well as a boost in funding for research and development. When people become captivated by the idea of exploring the cosmos, they are more likely to advocate for scientific progress and the allocation of resources to fuel future space endeavors. As space exploration continues to capture the human imagination, the delicate balance between scientific curiosity, technological innovation, and cultural interpretation will continue to shape how we approach the mysteries of the universe. Each new discovery, whether it challenges our assumptions or deepens our understanding, serves to reinforce the central role that space exploration plays in our quest for knowledge, survival, and connection to the vastness of the cosmos. The intersection of scientific accuracy and popular media remains a powerful yet complex force, capable of driving both enlightenment and misunderstanding. While some filmmakers and writers diligently adhere to scientific principles, enhancing the educational value of their narratives, others inadvertently distort facts, leading to confusion. When popular culture gets it right, it can serve as a conduit for disseminating knowledge, introducing audiences to accurate concepts of science, space, and the cosmos. However, the portrayal of inaccurate or exaggerated scientific phenomena often leads to misconceptions, particularly in the realm of physics and astronomy. Take, for instance, the portrayal of gravity, or the mechanics of space travel. These ideas are often presented in a way that overlooks or oversimplifies the complexities of these phenomena. As a result, audiences are led to believe that the laws governing space are far more lenient than they truly are. Such misconceptions shape public understanding, leading many to accept as truth what is nothing more than fiction. This is where the collaboration between filmmakers and scientists comes into play. Many contemporary films now consult experts, ensuring that the scientific elements depicted in these stories are as accurate as possible. This partnership elevates the quality of storytelling, transforming what could be mere entertainment into an opportunity for education. These films don't just entertain, they also serve as a bridge between the realms of science and entertainment. The influence of popular media on the public's perception of space exploration is far-reaching, guiding not only how we perceive the cosmos, but also how we approach the exploration of it. With space exploration so intrinsically tied to both scientific inquiry and public fascination, the role of institutions that bridge these two worlds becomes indispensable. Scientific institutions such as universities, research centers, and observatories play a crucial role in fostering public interest and understanding. These organizations, while focused on advancing research, also dedicate themselves to communicating their findings to the broader public. Their mission is not just to seek answers, but to help the world understand the deeper mysteries of the universe. Through public lectures, educational outreach programs, and interactive exhibits, they make complex scientific principles accessible to all, inviting engagement and curiosity. The primary goal of these efforts is to spark an interest in topics like dark matter, black holes, and the origin of the universe. Moreover, these institutions ensure that the discussions they generate are not limited to an academic audience, but are inclusive and wide-reaching. In this way, they encourage ordinary citizens to engage with the unknown, empowering them to ask questions and explore phenomena that were once thought to be beyond their grasp. This effort to make the mysteries of the cosmos accessible helps individuals connect these distant phenomena to their everyday lives, showing how an understanding of space can enlighten us on fundamental principles like time, space, and our place in the universe. The growing popularity of media-driven scientific explorations, such as documentaries, podcasts, and articles, further amplifies public engagement. These collaborations between scientific institutions and media outlets serve as a conduit for the dissemination of knowledge, translating complicated research into relatable narratives. By telling the stories of scientific discovery in a way that is both engaging and easy to understand, these platforms help nurture a greater appreciation for space exploration and its many complexities. As more and more people are drawn to the allure of the cosmos, the quest to uncover its mysteries becomes a shared experience, a journey that spans beyond the walls of laboratories and research stations to become a collective societal endeavor. A key facet of modern scientific institutions is their emphasis on inclusivity. Recognizing that diverse voices lead to a richer, more complete understanding of the universe, many institutions now actively work to diversify the scientific community. This inclusivity brings fresh perspectives that challenge conventional thinking and provide new angles from which to view age-old questions. By welcoming individuals from a variety of backgrounds, these organizations create a more nuanced, holistic view of the universe, one that invites people from all walks of life to contribute to the global conversation. As public interest in space grows, so too does the drive to answer the profound questions that remain unanswered. The important legacy of scientific institutions is evident in how they have shaped society's ongoing quest for understanding, providing the foundation for countless discoveries that continue to inspire future generations. However, as with any field of study, science is not without its inherent biases. Scientists, despite their commitment to objectivity, bring their personal beliefs, cultural backgrounds, and prior experiences into their work. These influences often affect the questions they ask and the way they interpret data. For example, the biases embedded in prevailing scientific paradigms can sometimes limit the scope of inquiry, leading researchers to focus on certain phenomena while overlooking others. This can manifest in what is known as confirmation bias, the tendency to seek evidence that supports a pre-existing belief or hypothesis while disregarding data that may challenge it. The study of the origins of the universe provides a compelling example of how scientific biases can shape research. For much of the 20th century, the Big Bang Theory was the dominant model, and alternative theories were often met with skepticism, even in the face of conflicting evidence. It wasn't until new data emerged that challenged the prevailing view that alternative models began to gain traction. This process of scientific evolution demonstrates the importance of remaining open-minded and flexible in the face of new information. On the flip side, biases in scientific inquiry can also lead to groundbreaking discoveries. When researchers challenge conventional wisdom and approach problems from unconventional perspectives, they open up the possibility for entirely new paradigms. A prime example of this is the discovery of dark matter and dark energy. Initially, many scientists were skeptical of these concepts, but the accumulation of unusual observational data gradually forced the scientific community to take them seriously. This paradigm shift highlights the potential of questioning long-held assumptions and pursuing research from novel angles. The key to unlocking these deeper insights lies in fostering an environment that encourages both creativity and rigorous skepticism. The scientific community must prioritize collaboration and open dialogue, ensuring that diverse perspectives are integrated into the process of discovery. Such collaboration can help mitigate the impact of individual biases and lead to a more holistic understanding of the universe. As we continue our pursuit of knowledge about the cosmos, it is essential to recognize and reflect on our biases. By doing so, we expand the scope of our investigations and open the door to new revelations that could forever alter our understanding of reality. The exploration of cosmic anomalies, strange and often unfathomable phenomena, serves as a microcosm of the larger philosophical questions about truth. When astronomers detect phenomena like black holes, dark matter, or gravitational waves, they are not merely solving puzzles about the physical universe. They are also engaging in a deeper philosophical inquiry about what it means to know something truly. In this pursuit, scientists rely heavily on empirical evidence, observations, and the scientific method to guide their understanding. However, the very process of uncovering truths about the cosmos often forces us to reevaluate the parameters we use to define truth itself. What does it mean to know something with certainty? Is the truth we uncover through science the ultimate truth, or merely a glimpse of something far more complex? These are questions that continue to shape the trajectory of scientific inquiry and the public's understanding of the universe, offering a never-ending journey of discovery that transcends both science and philosophy. Cosmic anomalies stand as one of the greatest challenges to established scientific frameworks, urging researchers to reevaluate the very nature of knowledge itself. These phenomena, which lie beyond the reach of conventional observation, force us to confront profound questions about the universe, knowledge, and perception. For example, dark matter, a mysterious substance that makes up a large portion of the cosmos, cannot be directly seen or measured. Instead, its existence is inferred through the gravitational effects it exerts on visible matter, light, and the structure of the universe itself. This reliance on indirect evidence raises an essential issue. Can we trust the validity of a truth that is based solely on inference, without direct observation? What does it mean to know something that we cannot see, touch, or measure in traditional ways? These questions delve into the heart of both scientific and philosophical inquiry. They challenge not only our understanding of the cosmos, but also the very nature of belief and skepticism. As scientists uncover new anomalies and make groundbreaking discoveries, long-standing theories are often upended, leaving behind paths for further exploration. This dynamic process illustrates a fundamental truth about science. Knowledge is not static. It evolves in response to new evidence, and our interpretations of the universe are always provisional. The journey of discovery in science is as much about the questions we ask as it is about the answers we find. Philosophically, this evolution of understanding suggests that truth itself is not a fixed, immutable concept. Rather, it is a dynamic and ongoing negotiation shaped by our ever-evolving interpretations of the world. Every new discovery invites us to reconsider not just what we know, but also how we know it and what we can never fully grasp. The existence of dark matter, the behavior of quantum particles, or the structure of distant galaxies. These mysteries remind us that our perceptions of reality are incomplete, and that the boundaries of what we can know are defined by the tools, technologies, and concepts we have at our disposal. Ultimately, cosmic anomalies compel us to confront our limitations in understanding the universe. As we seek to unravel the mysteries of the cosmos, we become more aware of the gaps in our knowledge and the limits of our perception. This tension between observation and interpretation, the dance between the tangible and the theoretical, underscores a crucial point. The pursuit of knowledge is a journey, not a destination. And often, it is in the very uncertainties of the unknown that we find the most profound insights. At the core of scientific inquiry is the recognition that uncertainty is not something to be feared, but embraced. In fact, it is the willingness to confront the unknown that drives innovation and discovery. Science thrives on observation and experimentation, methods that are inherently subject to unknown variables and complexities. When scientists venture into the depths of space to study phenomena such as dark matter, the origins of life, or the behavior of quantum particles, they are often confronted with questions that have no immediate answers. Rather than discouraging researchers, this uncertainty serves as a catalyst for new ideas, encouraging the development of fresh theories and approaches. Embracing what we do not know can be as valuable as understanding what we do know. It fosters a culture of curiosity, open-mindedness, and patience, creating an environment where bold ideas can flourish. For example, the theories surrounding the Big Bang or black holes have undergone significant evolution over time as new evidence has prompted revisions and adjustments to previously held beliefs. This iterative process is a hallmark of scientific advancement, highlighting the importance of questioning, revising hypotheses, and adapting to new data. Science, in this sense, is not about reaching a final answer, but about refining our understanding over time, always with an eye toward the future. Moreover, uncertainty fosters collaboration across disciplines. When scientists acknowledge the limitations of their knowledge, they are more likely to seek insights from a wide range of fields, resulting in interdisciplinary approaches that can lead to richer, more nuanced understandings of complex phenomena. Issues like the nature of consciousness, the mechanics of gravity, and the fundamental forces of the universe require diverse perspectives and expertise. By drawing on a variety of scientific traditions, researchers can tackle questions that were once considered too complex or paradoxical for a single field to resolve. Ultimately, the acceptance of uncertainty is not a weakness, but a strength. It is a recognition of the vastness of the unknown, a call to continue exploring, questioning, and discovering. This acceptance drives the ever-expanding quest for knowledge, propelling scientists forward even when the answers are elusive. It is this same uncertainty that often leads to the most profound revelations, guiding us toward a deeper understanding of the universe and our place within it. In science, the unknown is not a barrier. It is a doorway to new insights. Current scientific paradigms, though powerful and capable of explaining a wide range of phenomena, often encounter limitations when it comes to grappling with the mysteries of the cosmos. One of the most significant challenges lies in the fact that these paradigms are based on established theories, some of which may not fully account for the complexities of the universe. For instance, general relativity, Einstein's theory of gravity, describes the behavior of large-scale objects like planets and galaxies with remarkable accuracy. However, when applied to the realm of quantum mechanics, which governs the behavior of particles at the smallest scales, general relativity falls short, highlighting a fundamental disconnect between two of the most successful theories in modern physics. This gap in our understanding underscores a crucial limitation of current scientific frameworks. While general relativity and quantum mechanics both offer profound insights into the workings of the universe, they do not yet form a unified theory that can explain both the very large and the very small. This leaves a hole in our knowledge that will only be filled through further research, experimentation, and most likely, the development of new theories that can bridge the gap between these two domains. Another major challenge lies in the methods scientists use to gather data about the universe. Traditional observational techniques, which rely on detecting electromagnetic radiation such as visible light, radio waves, and gamma rays, are limited in their ability to explore certain types of celestial phenomena. For example, dark matter and dark energy, which together account for the vast majority of the universe's mass and energy, cannot be directly observed using these conventional methods. Instead, scientists are forced to rely on indirect techniques, such as observing the gravitational effects of these invisible forces, making the study of these phenomena particularly challenging and uncertain. This reliance on indirect evidence creates a fundamental problem. How can scientists be certain of something that cannot be directly measured or seen? While these challenges have led to debates and disagreements within the scientific community, they have also spurred new lines of inquiry and alternative approaches. As our tools and technologies improve, we may one day find new ways to directly observe or measure these elusive phenomena, leading to breakthroughs that transform our understanding of the universe. In the end, the mysteries of the cosmos, whether it be dark matter, quantum particles, or the nature of space-time itself, serve as powerful reminders of the limits of human knowledge and perception. They invite us to question not only what we know, but also how we know it, challenging us to reconsider the very foundations of science and philosophy. The pursuit of answers to these cosmic anomalies may be slow and uncertain, but it is also what drives scientific discovery, pushing us to the edges of understanding and beyond. In the face of the unknown, we are reminded that the journey of exploration, marked by questions, uncertainty, and discovery, is as vital as the answers themselves. Furthermore, human biases and conceptual frameworks often impose significant limitations on scientific inquiry. Once a theory has been established and widely accepted, it can become exceedingly difficult to modify or replace, even when confronted with new, compelling evidence. This phenomenon, known as cognitive bias, plays a crucial role in stifling progress. It leads to a resistance to new ideas, especially when they challenge well-established doctrines. The reluctance to reconsider long-standing theories can slow the pace of discovery, as groundbreaking concepts such as string theory or the multiverse theory often take years, if not decades, to gain widespread acceptance. Despite their profound potential to unlock the mysteries of the cosmos, these theories struggle to find traction because they challenge deeply entrenched perspectives. In light of this, it becomes increasingly clear that the integration of interdisciplinary approaches is essential for overcoming these biases. Drawing from fields as diverse as philosophy, mathematics, and even art can help foster creativity and inspire new avenues of exploration. By broadening the scope of inquiry, scientists can approach cosmic phenomena from fresh, innovative angles. The infusion of ideas from other disciplines enriches the research process, offering new tools and frameworks for tackling questions that, for all their importance, have often remained beyond our grasp. This kind of cross-disciplinary approach empowers scientists to go beyond the limits imposed by traditional thinking, enabling them to pursue new avenues of inquiry with a renewed sense of possibility. History has shown us time and again that scientific advancement is not a linear path, but a complex, sometimes tortuous journey. Each era of scientific exploration has been marked by breakthroughs that were often fueled by the unyielding desire to understand the unknown. The methodologies used by past scientists can provide valuable insights that inform modern approaches to investigating unexplained phenomena. By examining the ways in which thinkers like Galileo Galilei and Isaac Newton approached the great questions of motion and gravity, we can gain a deeper appreciation for the techniques, challenges, and triumphs that defined their work. These foundational insights laid the groundwork for the scientific methods we still rely on today. The importance of empirical evidence, honed through careful observation and experimentation, remains central to the scientific method. When faced with an unexplained phenomenon, modern scientists follow in the footsteps of their predecessors, applying rigorous empirical approaches to test hypotheses. Thanks to technological advancements and collaborative platforms, today's researchers have tools at their disposal that early scientists could only dream of. Yet, in many ways, the spirit of persistence that characterized the great breakthroughs of history continues to be just as vital. Progress in science often requires patience, and modern discoveries are often the result of incremental steps taken over many years, if not centuries. The setbacks and missteps of the past also hold valuable lessons. The history of science is littered with instances where new ideas were dismissed, not because they were flawed, but because the prevailing tools and conceptual frameworks were insufficient to fully comprehend their complexities. These examples underscore the importance of remaining open-minded and adaptable. Scientific progress depends on the willingness to revise existing theories, challenge long-held beliefs, and embrace new ideas, especially those that seem to defy conventional wisdom. By learning from the past, modern researchers can refine their approaches and avoid the pitfalls that hindered earlier efforts. When we look at how scientists have tackled seemingly intractable problems over the centuries, it becomes evident that the willingness to integrate historical perspectives with contemporary methods is essential. This creates a richer, more nuanced approach to inquiry, allowing scientists to honor the legacies of their predecessors while simultaneously breaking new ground. By synthesizing old and new, theory and practice, science moves forward, often in unexpected and transformative ways. The scientific method, at its core, is a dynamic, flexible process that adjusts to accommodate new challenges and anomalies. One of the first adjustments researchers make when encountering phenomena that defy existing explanations is the development of new hypotheses. These hypotheses serve as potential answers, carefully crafted to be tested through observation and experimentation. This iterative process ensures that science remains a continually evolving field, with ideas being refined or discarded in light of new evidence. Additionally, when traditional methods of testing fail, interdisciplinary collaboration becomes essential. Insights drawn from fields such as physics, biology, chemistry, and engineering allow scientists to approach problems from a variety of perspectives. This cross-pollination of ideas can often spark fresh insights, offering novel solutions to complex issues that would be difficult to tackle from within the confines of a single discipline. The blending of diverse expertise leads to more holistic, creative solutions to cosmic mysteries, often yielding results that were previously unimaginable. In particularly challenging cases where phenomena seem almost impossible to quantify, scientists may turn to advanced technologies and innovative methodologies. For example, sophisticated imaging techniques in biology or high-energy particle colliders in physics can reveal insights into the very building blocks of matter. These cutting-edge tools allow researchers to peer deeper into the fabric of the universe, uncovering hidden truths that bring us closer to solving some of science's most profound puzzles. Moreover, the principle of falsifiability, the idea that the scientific hypothesis must be testable and, if necessary, disprovable, remains one of the bedrocks of the scientific method. It forces researchers to abandon outdated or incorrect ideas and encourages them to explore new avenues of thought. This adaptability is what drives scientific progress, allowing research to persist in the face of challenges and thrive on the very enigmas that once seemed insurmountable. By maintaining this flexibility, science continuously pushes the boundaries of our understanding, revealing new dimensions of reality and providing us with a deeper understanding of the universe. At the heart of scientific exploration is the understanding that every researcher brings a unique perspective to their work. This lens through which they view the world is shaped by their individual beliefs, cultural backgrounds, education, and personal experiences. These factors can profoundly influence how they interpret the data they collect and the conclusions they draw. Whether studying dark matter, black holes, or the cosmic microwave background radiation, the questions scientists ask and the hypotheses they formulate are often colored by their worldview. For instance, a scientist who subscribes to a deterministic view of the universe might interpret cosmic anomalies as the manifestation of unknown forces that still obey the fundamental laws of physics. Their belief in an orderly, predictable universe may lead them to seek explanations that fit within the existing frameworks of physical law. In contrast, another scientist with a more open-ended or philosophical perspective might explore speculative theories, challenging conventional wisdom, and looking beyond the established paradigms of physics. They might consider alternative explanations that defy current understanding, perhaps pointing to the possibility of new laws of nature yet to be discovered. The history of science is rife with examples where personal beliefs and cultural contexts have shaped scientific interpretations. In the early 20th century, for example, many scientists were hesitant to embrace the radical implications of quantum mechanics. The theory's bizarre and counterintuitive nature conflicted with the classical Newtonian worldview, making it difficult for many to accept. Today, however, quantum mechanics is a cornerstone of modern physics, illustrating how shifts in scientific thinking, fueled by new evidence and evolving perspectives, can lead to revolutionary breakthroughs. As we move forward, it is crucial to remember that science is an ever-evolving journey. Personal biases, societal influences, and historical contexts will continue to shape scientific inquiry, but by remaining open-minded and adaptable, researchers can continue to unlock the secrets of the cosmos, one discovery at a time. As our understanding of the cosmos continues to grow, researchers often find themselves confronting entrenched paradigms, with their personal worldviews influencing their reactions to new and groundbreaking ideas. The challenge is not merely one of analyzing data, but involves a deeper and more intricate process of interpretation. The interpretation of cosmic anomalies in particular is not just an academic exercise. It represents a complex, nuanced interaction between raw facts, scientific theories, and individual beliefs. In this arena, knowledge is never purely objective, and one's worldview inevitably shapes how we perceive the universe. This reality forces us to confront the broader, often philosophical implications of our beliefs, questioning how our personal perspectives can obscure or illuminate our understanding of the cosmos and its myriad mysteries. At the heart of scientific discovery, there exists an unexpected yet powerful force: serendipity. Serendipity, that fortuitous blend of chance and circumstance, serves as a remarkable catalyst in the world of science. It's in these moments of unplanned discovery that some of the most revolutionary breakthroughs occur, often when researchers least expect them. Frequently, these are the result of a scientist pursuing one line of inquiry only to stumble upon something entirely different, and as it turns out, profoundly significant. One of the most famous examples of such a serendipitous moment is the discovery of penicillin by Alexander Fleming. In 1928, while experimenting with bacteria cultures, Fleming noticed something unusual. A mold had formed on one of his petri dishes, and the bacteria surrounding it had been destroyed. This accidental observation, one that seemed so trivial at the time, would go on to change the face of medicine forever, marking the beginning of the antibiotic era. This discovery illustrates the unpredictable nature of scientific research, where luck plays a role as important as methodical experimentation. However, the role of chance in scientific progress is not just anecdotal. It reflects a larger truth about the nature of discovery itself. Often, the discoveries that alter the course of history are not the ones researchers were originally searching for, but rather the ones they encounter through unanticipated outcomes or observations that defy existing theories. These unexpected moments of insight force the scientific community to reevaluate established ideas, challenging long-held beliefs, and pushing the boundaries of knowledge in ways that would not have been possible through traditional, hypothesis-driven inquiry. Moreover, serendipitous discoveries are often intertwined with creativity and a willingness to think outside the box. When researchers approach their work with an open mind, free from rigid expectations, they create fertile ground for unexpected breakthroughs. In such environments, the ability to see the potential significance in an unforeseen result is paramount. It is this openness to the unexpected that leads to some of the most transformative moments in scientific history. Some scientists even introduce elements of chance into their experiments, deliberately incorporating randomization to uncover insights that might have otherwise gone unnoticed. This intersection of intentional inquiry and serendipitous discovery is at the core of the scientific process. The path of exploration is rarely linear, and as scientists navigate the unknown, their ability to remain flexible, to pivot in response to surprising results, enhances the depth and breadth of their investigations. Such moments of serendipity not only enrich individual scientific endeavors, but contribute to a collective understanding that reshapes the way we view the world and the universe beyond. Thus, serendipity is not just an unpredictable twist in the tale of scientific discovery. It is a fundamental force that drives progress. The discoveries made through these fortuitous moments often define our understanding of the universe, revealing new truths that were once unimaginable. It is a reminder that the journey of scientific exploration is not solely about following a predetermined path, but also about embracing the unknown, accepting the unexpected, and recognizing the profound implications that these moments can have on the course of human knowledge. The quest for knowledge is an enduring theme that runs through human history. It is a journey driven by curiosity, exploration, and an unyielding desire to understand our place in the cosmos. Whether it is crossing oceans, scaling mountains, or venturing into the vast expanse of space, humanity has always been propelled forward by the urge to discover. It is this innate curiosity that pushes us to seek answers to the most fundamental questions about our existence. With each new discovery, new questions arise, fueling an endless cycle of inquiry that spans generations. Curiosity, in its most basic form, is the spark that ignites scientific progress. It is the driving force behind every exploration, whether it's into the depths of the ocean, the furthest reaches of the galaxy, or the smallest corners of our own biology. With every question asked, new avenues of exploration open up, and the pursuit of knowledge becomes ever more expansive. For example, it was curiosity that led early astronomers to look to the night sky. And through their observations, we now know that our Milky Way is just one of billions of galaxies in the universe. It was curiosity that led scientists to probe the forces that govern the motion of celestial bodies, laying the groundwork for the discovery of gravity and revolutionizing our understanding of the laws of nature. Curiosity is not confined to the pursuit of answers alone. It is about the questions themselves. It is the never-ending desire to understand that pushes humanity to explore new frontiers, both geographical and intellectual. With each discovery, we realize just how much we still have to learn, and this realization drives us to venture further into the unknown. This cycle of inquiry and discovery is what defines the essence of human exploration, a journey that is far from over, but one that continues to unfold as we look toward the future. Thus, it is the combination of curiosity, serendipity, and the willingness to embrace the unexpected that propels us ever forward. These elements work in tandem to shape the course of scientific exploration, allowing us to push the boundaries of what we know and, in turn, redefine our place in the universe. It is in this dynamic interplay between intention and chance that we find some of the most profound and transformative moments in the history of discovery. Moreover, the human spirit stands as a testament to resilience and determination, a force that has driven humanity through countless eras of adversity. Throughout history, individuals have faced monumental challenges in their relentless pursuit of knowledge. These journeys, often fraught with danger, hardship, and uncertainty, are not merely physical undertakings. They reflect the indomitable human will to push forward in the face of the unknown, embodying the very essence of perseverance. Explorers, scientists, and thinkers alike have overcome barriers that seemed insurmountable, motivated by an innate desire to understand the world and the universe beyond. The ascent of a mountain, the discovery of a new species, or the exploration of space through spacecraft that venture far beyond the confines of our solar system are not just physical feats. They are symbolic of the profound quest for intellectual and philosophical enlightenment. These pursuits represent a convergence of knowledge, exploration, curiosity, and the human spirit, an intricate tapestry of human experience that spans the limits of our capabilities. Each new expedition opens pathways to understanding, sparking the curiosity of future generations. It is a continuous cycle of exploration, one that constantly propels us forward and reminds us that the pursuit of knowledge is a journey with no end. This insatiable quest not only enriches our collective consciousness, but also reinforces the truth that the search for knowledge is one of the defining characteristics of humanity itself. The universe, in all its grandeur and mystery, continues to raise questions that fuel scientific inquiry and ignite philosophical reflection. As we seek to unravel the origins, vastness, and intricate laws of the cosmos, each discovery seems to open new realms of inquiry, bringing forth even more profound mysteries. Take, for instance, the enigmatic phenomena of dark matter and dark energy. These two entities, which make up the majority of the universe, remain elusive, continuing to puzzle scientists and philosophers alike. Yet, rather than dampening the pursuit, these mysteries spark deeper curiosity, urging us to question further, probe more intensely, and rethink everything we thought we knew. The pursuit of knowledge, driven by the power of curiosity, has pushed the boundaries of science and technology. As we stretch the limits of what is possible, exploring distant galaxies, probing the very fabric of reality, and developing technologies that could one day allow us to venture beyond the stars, we are forced to grapple with deeper philosophical questions. What does it mean to be conscious in a universe so vast? Are we alone in the cosmos? What is the nature of existence itself? These questions challenge our perceptions and prompt us to look beyond the empirical, seeking meaning in the unknown. The idea of a multiverse, for example, suggests that our universe may be but one of many, each existing alongside the others in a vast and incomprehensible reality. Such ideas force us to rethink our definitions of reality, perception, and existence. But with these great revelations also comes great responsibility. As our understanding of space, time, and the universe expands, so too do the ethical implications of scientific advancement. Technologies developed for the exploration of space, for instance, may one day allow us to colonize other planets or embark on journeys to distant stars. Yet, with such power comes the question, what is our responsibility toward other potential forms of life in the universe? What moral dilemmas will we face as we push further into the unknown? In this way, science and philosophy become intertwined, enriching each other. Philosophy enters the conversation not only to explore the ethical questions raised by scientific progress, but also to reflect on the deeper implications of our discoveries. As we venture further into the cosmos, we realize that the answers we seek may be just as much about who we are as a species as they are about the nature of the universe itself. The convergence of scientific discovery and philosophical thought creates a deeper understanding of our place in the cosmos, allowing us to explore not just the stars, but the very meaning of existence. As we continue to explore the complexities of the universe, it becomes increasingly clear that our persistent questioning is not just a tool for discovery, but a bridge between the empirical and the existential. This culture of inquiry nurtures scientific progress, while also prompting us to reflect on the larger meanings behind our findings. It is this interplay between the known and the unknown, between discovery and contemplation, that paints a richer, fuller picture of the human experience. Over the centuries, our attempts to understand the unexplained phenomena of the universe have led to profound lessons. Many of these lessons reflect a blend of scientific humility and the importance of adaptability in the face of new information. Early theories about the nature of the cosmos were often simplistic, rooted in philosophical musings rather than empirical evidence. For example, centuries ago, the prevailing belief in a geocentric universe, where Earth was seen as the center of everything, dominated our understanding of the cosmos. It wasn't until the work of astronomers like Nicolaus Copernicus and later Galileo Galilei that humanity shifted to the heliocentric model, understanding the solar system with greater accuracy. This paradigm shift was pivotal, not just in understanding the structure of our solar system, but in demonstrating the importance of challenging established norms in the pursuit of progress. Scientific inquiry, as history has shown, thrives when we are willing to question what we think we know, to challenge assumptions, and to embrace the unknown. More recent phenomena, such as dark matter and dark energy, serve as a testament to this same lesson. Initially proposed as a way to explain the strange behavior of galaxies and the expansion of the universe, these concepts have evolved into a major part of our understanding of the cosmos. Yet, despite the overwhelming evidence of their existence, these entities remain stubbornly elusive. They do not emit or absorb light, making them undetectable by traditional methods of observation. This has forced scientists to develop new, innovative tools, such as more sensitive telescopes and particle colliders, to gather indirect evidence and probe deeper into the nature of the universe. The adaptability shown in the face of these unknowns underscores a critical truth. Gaps in knowledge often lead to new avenues of discovery. Rather than retreating in the face of uncertainty, science thrives on the drive to develop new methodologies, to rethink our approach, and to constantly push the boundaries of what we know. In this way, each unanswered question becomes an invitation to explore further, revealing deeper layers of understanding and pushing us toward greater truths about the cosmos and our place within it. The story of scientific discovery unfolds not in isolated silos, but in a vast, interconnected network of collaboration. Time and time again, history has demonstrated the immense value of scientists working across disciplines, as groundbreaking insights often emerge from the fusion of knowledge from diverse fields. Consider the long-standing relationship between physics and astronomy, two domains once viewed as distinct, yet together they have unlocked some of the most profound secrets of the cosmos. This partnership has led to the discovery of extraordinary phenomena like black holes and gravitational waves. These insights were made possible not by working in isolation, but through the synthesis of ideas from different scientific realms. It becomes clear the universe operates not as a collection of disconnected phenomena, but as a seamless, interconnected whole. To truly understand its workings, scientists must be willing to transcend disciplinary boundaries. This approach, rooted in openness to interdisciplinary collaboration, has become a guiding principle of modern science. When confronted with the unknown, it's often clear that a singular perspective will not suffice. Phenomena that baffle us today often require the expertise of multiple fields to be fully understood. It is through this collaborative spirit that we can begin to unravel the mysteries that have persisted for centuries. This is especially true in the search for a complete theory of quantum gravity, an enigma that has eluded physicists for decades. Despite the formidable challenges that lie ahead, the journey of discovery continues, driven by the ceaseless curiosity of those who are determined to understand the cosmos. The relentless pursuit of knowledge, sometimes over the course of decades or even centuries, highlights an essential truth about science. Discovery is not an instantaneous process, but a journey that demands patience and persistence. Each small breakthrough not only advances our understanding, but also becomes part of a larger, ever-expanding story. This story is written by countless individuals, each contributing to the greater human endeavor. It is a dynamic, ongoing dance of inquiry, a constant push against the boundaries of the unknown. As future generations take up the mantle of exploration, they will stand on the shoulders of giants, scientists and thinkers who have come before them, whose contributions have shaped our understanding of the universe. Armed with the tools and knowledge passed down from previous generations, the next wave of explorers must be ready to face the questions that await. To do so, they must embody a blend of curiosity, critical thinking, and collaboration. The universe is vast, and its mysteries are many, but every discovery leads to more questions, which in turn reveal the interconnected nature of reality itself. Therefore, the future of scientific inquiry will be defined not only by the answers we uncover, but by the questions we dare to ask. In this spirit, interdisciplinary collaboration will remain a cornerstone of scientific progress. Cosmic mysteries touch on a wide range of fields, from astrophysics and quantum mechanics to philosophy. It is by merging the empirical methods of scientists with the theoretical frameworks of thinkers from various disciplines that we can hope to make significant strides in cosmic exploration. Such collaborations will not only strengthen the research process, but will also spark fresh perspectives and creative ideas, shedding light on even the darkest corners of the universe. The tools available to future scientists will be more powerful than ever before. With each technological advancement, from the construction of more sophisticated telescopes to the development of cutting-edge algorithms for analyzing massive data sets, the potential for discovery expands exponentially. Yet, with this incredible potential comes a unique responsibility. Future generations must not only know how to use these tools, but also how to imagine and create the tools of tomorrow. The cycle of discovery is unending, and to keep pushing the boundaries of what we know, we must be prepared to continually innovate and adapt. Equally important is a sense of stewardship, a commitment to understanding the ethical implications of our pursuit of knowledge. As we explore the cosmos, we must not forget our responsibility to our own planet and to each other. The discoveries we make should not only serve the advancement of science, but should also reflect a deep respect for the universe we seek to understand. Future scientists must approach cosmic mysteries not only as researchers, but as custodians of knowledge, driven by a passion to share their findings with others and inspire new generations to join the quest. The journey of discovery, fueled by a spirit of wonder and responsibility, will be as transformative as it is illuminating. The anomalies we encounter in our exploration of the universe serve as profound reflections of both our curiosity and our limitations. From dark matter and dark energy to the perplexing behavior of black holes, these cosmic puzzles raise fundamental questions about the very nature of reality. Each new discovery, each new anomaly, pushes the boundaries of our existing understanding and forces us to rethink the frameworks through which we interpret the cosmos. Even when discoveries challenge the status quo or fail to provide answers, they nonetheless advance the frontier of knowledge, inching us closer to the ultimate truth that lies hidden within the cosmos. Every new observation, whether it be the strange glow of fast radio bursts or the inexplicable movements of galaxies, serves as a humbling reminder of how much we still have to learn. These discoveries confront us with the reality that, despite our remarkable achievements, we are only beginning to scratch the surface of what the universe holds. As we continue to explore, we encounter not only the mysteries of the cosmos, but also the limitations of our own understanding, revealing that our scientific advancements are but stepping stones in a much larger journey. The more we learn, the more we realize how much we have yet to uncover. In this ongoing pursuit of knowledge, the value of collaboration between disciplines becomes even clearer. Physicists, astronomers, and even philosophers are increasingly finding themselves working together, each contributing a unique perspective to the collective effort. The anomalies we encounter often raise fundamental questions about time, space, and the very nature of existence itself. These questions cannot be answered by a single discipline alone. Instead, they require a broader, more holistic approach, one that recognizes the interconnections between various fields of study. The search for answers becomes an exploration not just of the universe, but of the very frameworks through which we understand reality. In the end, the journey to uncover the mysteries of the universe is not just about finding answers. It's about the process of discovery itself. It's about embracing the unknown, recognizing the value of diverse perspectives, and pushing the limits of human understanding. The mysteries we encounter along the way are not roadblocks, but invitations, inviting us to expand our minds and deepen our curiosity, all while reminding us of the vast, interconnected web that binds us to the cosmos. Contemplating the vast, unexplained anomalies that exist in the cosmos evokes a sense of awe and humility. As we confront questions that might never have definitive answers, we are reminded of the delicate and transient nature of our existence within this immense universe. The very mysteries that we struggle to understand seem to reach out, urging us to continue exploring, to push further into the unknown. It is through this ongoing pursuit of knowledge that we find meaning, not just in the facts we uncover, but in the act of discovery itself. This relentless journey of exploration nurtures not only our understanding of the cosmos, but also a deep, enduring respect for the mysteries that remain far beyond our grasp. By recognizing the gaps in our knowledge, we ignite curiosity and fuel the drive for exploration. These gaps, rather than being seen as mere voids, act as powerful catalysts for scientific inquiry. When scientists come face to face with the unknown, they are not deterred. Instead, they are inspired to venture into uncharted territories, to question the very foundations of what we think we know. The identification of what remains to be discovered does more than just highlight the limitations of current knowledge. It provides a roadmap for future exploration. It becomes a playground for innovative ideas, a fertile ground for groundbreaking experiments that will reshape our understanding. Many of the most transformative breakthroughs in science were born from the recognition of what was not yet understood. For example, the pursuit to understand the enigma of dark matter and dark energy arose precisely because the laws of conventional physics could not fully account for the behavior of the universe. This realization prompted physicists and astronomers to think outside traditional frameworks, proposing new theories, developing cutting-edge technologies, and conducting intricate experiments in an effort to unveil the hidden forces that shape the universe. Moreover, acknowledging the gaps in our knowledge often leads to collaboration across diverse disciplines. When experts from various fields come together, they create a melting pot of perspectives and ideas, each contributing a unique approach to solving complex problems. A prime example of this interdisciplinary collaboration can be found in the Human Genome Project. Biologists, chemists, and data scientists worked hand in hand, pooling their expertise to unlock insights into genetics and revolutionize our understanding of medicine. This recognition of our intellectual limitations invigorates the scientific community, propelling us forward in the unyielding quest for knowledge. It awakens a sense of wonder, encouraging us to ask more questions, challenge established paradigms, and ultimately expand the horizons of human understanding. Every gap in our knowledge is not merely an absence, but a beacon, lighting the way toward new discoveries yet to be made. The quest to uncover the cosmic mysteries that have baffled scientists for generations has profound implications for humanity. As we push the boundaries of our understanding, we gain insights that transcend mere academic curiosity. Understanding phenomena like dark matter and dark energy, for instance, could completely alter our grasp of the laws that govern the universe. The implications of such discoveries might be far-reaching, potentially leading to new technologies, revolutionary energy sources, and an entirely new way of living on Earth, and even beyond it. On a more philosophical level, resolving the mysteries of the cosmos could rekindle humanity's sense of purpose, inspiring us to reflect on our place in the vast expanse of existence. Discovering the origins of galaxies, stars, or even life itself challenges our preconceived notions, compelling us to reassess our relationship with our planet and with one another. Questions about whether we are truly alone in the universe or if intelligent life exists elsewhere may not only reshape scientific theories, but could also redefine our cultural narratives, creating a shared sense of purpose and unity in the pursuit of knowledge. In addition to fostering a deeper connection with the universe, cosmic inquiries often spark technological innovation. Many of the advances we take for granted in our everyday lives, such as improved medical imaging, have their origins in research driven by the need for astronomical observation. The technologies developed to explore space often find applications in other areas, benefiting society in ways we might not immediately recognize. For example, the creation of advanced imaging tools for space telescopes has led to significant improvements in the clarity of medical scans, allowing doctors to diagnose and treat diseases with unprecedented precision. As humanity stands on the precipice of these discoveries, the potential impacts of unraveling cosmic mysteries extend far beyond the realm of science and technology. They touch on questions of philosophy, culture, and our collective identity. Our quest to understand the universe is not merely about studying the stars. It is about discovering deeper connections among ourselves, forging a more enlightened and interconnected human race. Every new revelation brings with it a host of new questions, ensuring that the journey of exploration is an endless cycle, one that is as transformative as it is enlightening. The pursuit of these cosmic mysteries has the potential to yield not only profound insights into the nature of the universe, but also tangible benefits for humanity. By delving into the unknown, we stand to unlock breakthroughs in technology and energy that could dramatically reshape our future. Space exploration, for instance, has historically been a catalyst for innovation in a wide range of fields, from communications technology to medical advancements. The tools developed for studying distant galaxies often lead to breakthroughs that improve our daily lives. Exploring phenomena such as dark matter and dark energy could open up entirely new areas of physics, challenging the foundational principles that govern our understanding of the universe. This pursuit might even lead to the creation of new technologies designed to measure and harness these forces, offering solutions to some of the most pressing challenges we face, such as sustainable energy. Theoretical concepts developed to explain these cosmic mysteries could eventually give rise to new paradigms in science and engineering that we can scarcely imagine today. In this way, the search for answers to the great unknowns of the universe may not only expand our knowledge, but could also lay the foundation for innovations that improve life on Earth for generations to come. The quest to unravel the mysteries of the cosmos has become a powerful force that brings together people across cultures and disciplines. It opens up countless opportunities for collaboration, uniting scientists, researchers, and thinkers from various fields. As they engage in the pursuit of knowledge about the universe, they contribute to a global effort that transcends geographical and ideological boundaries. This collective journey not only fosters innovation in science, technology, engineering, and mathematics, but also inspires a new generation of students to explore these fields. In doing so, young minds acquire skills that are applicable across a wide array of sectors on Earth, from healthcare to technology to environmental conservation. Through this ongoing collaboration, individuals develop a broad spectrum of problem-solving abilities, critical thinking skills, and technical expertise that can be applied to solve real-world challenges. The pursuit of understanding the universe thus serves as a catalyst for creativity and ingenuity in addressing issues on our own planet. At its core, this endeavor reflects our deep desire to understand not only the universe itself, but also our place within it. As humanity delves deeper into the vastness of space, it's essential to consider the implications of our newfound knowledge. Understanding the intricacies of the universe can shift our perspective on Earth and our existence. Realizing that we are but a small part of a much larger cosmic story helps to highlight the interconnectedness of all things. This awareness can foster a sense of shared responsibility toward each other and the environment. A collective understanding of our position in the cosmos can propel us toward more sustainable practices and global cooperation in the face of pressing issues like climate change. The mysteries of space also remind us of the countless unknowns that still lie ahead, urging us to continue exploring. This sense of excitement and curiosity is a driving force that has the potential to propel society toward a brighter, more informed future. With every new discovery, we uncover more about the universe's complex design, pushing us to question what we know and sparking the imagination of both scientists and the general public alike. As we venture further into the unknown, several fundamental questions continue to shape the direction of our research. One of the most perplexing is the nature of dark matter, a mysterious substance that constitutes about 27% of the universe. Despite extensive observations, scientists have yet to fully understand its properties. Dark matter interacts gravitationally with visible matter, but it does not emit, absorb, or reflect light, making it nearly impossible to detect directly. This enigma challenges the very foundations of our understanding of physics, compelling researchers to explore various hypotheses regarding its composition and behavior. Equally elusive is dark energy, which accounts for approximately 73% of the universe. This mysterious force is driving the accelerated expansion of space, but its true nature remains one of the most profound puzzles in modern science. Understanding dark energy could offer invaluable insights into the universe's future, including its eventual fate. As scientists continue to study this phenomenon, they explore various models and theories to determine how dark energy fits into the larger picture of cosmic evolution. Another exciting frontier of research lies in the realm of gravitational waves, which were first detected in 2015. These ripples in space-time offer a new way to observe and understand cosmic events. The study of gravitational waves has the potential to deepen our understanding of some of the universe's most violent and mysterious phenomena, such as black hole mergers and neutron star collisions. These waves could also reveal secrets about the conditions that existed in the early universe, providing crucial insights into the very fabric of space-time. The question of life beyond Earth also continues to captivate the scientific community and the public. As we discover more about exoplanets and the conditions that could support life, researchers are keen to understand the potential forms that life might take and whether it could thrive in extreme environments. Could there be intelligent beings elsewhere in the universe? What are the chances of finding life in the far reaches of space? These questions challenge our assumptions about life and force us to rethink our place in the cosmos. This journey of exploration is driven by these and many other compelling questions. They push the boundaries of human knowledge and encourage us to think deeply about the universe and our place in it. As we seek answers, we are reminded of the need to balance scientific exploration with philosophical reflection. Understanding the cosmos involves not only gathering empirical data, but also contemplating the larger implications of our discoveries. Scientific exploration gives us the tools to observe, experiment, and analyze the universe. Through observations of distant stars and galaxies, the discovery of gravitational waves, and the study of dark matter, we begin to piece together the puzzle of cosmic evolution. However, scientific inquiry is not merely about collecting data. It is about developing theories that help us make sense of the universe. For example, the detection of gravitational waves not only confirmed Albert Einstein's predictions from over a century ago, but also expanded our understanding of the fundamental structure of space-time. Philosophy, on the other hand, provides the framework to ask deeper questions. What does it mean to exist in such an enormous and mysterious universe? What is the nature of consciousness, and how does it relate to the cosmos? Does the universe have a purpose, or is it an accident of cosmic forces? Philosophical inquiry encourages us to explore the implications of these questions, enriching our interpretations of scientific discoveries and helping us to reflect on the ethical dimensions of space exploration. When science and philosophy are integrated, they create a dynamic dialogue that pushes both disciplines forward. For instance, the ongoing debate about the multiverse hypothesis, whether there are countless other universes beyond our own, raises questions about the very nature of existence. While scientists explore the potential properties of these hypothetical universes, philosophers ponder what it means for our understanding of reality if such worlds do exist. This collaborative interplay between science and philosophy can also enhance the way we approach practical challenges in space exploration. For example, as we consider the possibility of colonizing other planets or making contact with extraterrestrial civilizations, ethical questions arise. Should humanity expand beyond Earth, and if so, how can we ensure that we do so responsibly? Philosophical inquiry helps frame these questions, while scientific research provides the knowledge needed to answer them. Similarly, collaborations across different scientific fields are instrumental in solving some of the universe's most profound mysteries. The fusion of physics, biology, chemistry, and astronomy leads to exciting new insights. Astrophysicists working alongside data scientists can unlock new ways of interpreting the vast amounts of information collected from telescopes and space missions. When biologists and chemists contribute their expertise, they deepen our understanding of life's potential to thrive in various cosmic environments, from distant planets to the most extreme conditions on Earth. By embracing a multidisciplinary approach, researchers can develop more comprehensive models that account for the complexities of the universe. This type of collaboration can lead to breakthroughs that would not be possible within the confines of a single field. As we continue to explore the cosmos, it is through such diverse collaborations that we will uncover the deepest secrets of the universe and further our understanding of our place within it. The exploration of the cosmos has long been a captivating endeavor, inviting both scientific and philosophical inquiry into the mysteries that lie beyond our Earth. As we venture further into the unknown, it is not only scientists and physicists who play crucial roles in this pursuit of knowledge. Experts from a wide range of fields, such as historians, ethicists, and philosophers, contribute invaluable insights into the broader implications of our discoveries. Their involvement brings a much-needed depth to the conversation, particularly when addressing the profound questions that arise as we confront the possibility of extraterrestrial life or grapple with the ethical considerations of space exploration. These disciplines offer unique perspectives, helping us contextualize cosmic discoveries within the fabric of society, culture, and our collective human experience. The dialogue between the sciences and the humanities enriches our understanding of the cosmos, providing a framework for interpreting the significance of discoveries that might otherwise be viewed as abstract or distant. For example, what does it mean for humanity to discover life beyond our planet? How do we ethically navigate the exploration of space, ensuring that our ambitions do not come at the cost of unintended consequences? These are not questions that can be answered solely through scientific data. They require the intellectual and moral input of thinkers from diverse fields. Ultimately, this collaborative effort, one that merges scientific rigor with philosophical reflection, creates a richer, more nuanced narrative about our place in the universe. Success in cosmic exploration can be defined in many ways, but it is most meaningful when considered through three intertwined dimensions: discovery, understanding, and inspiration. Each dimension plays a crucial role in propelling us forward in our pursuit of knowledge, guiding us through the complex and often perplexing questions that arise as we explore the universe. The first dimension, discovery, is the most immediate and tangible. It refers to the moments of revelation when we uncover new information or encounter phenomena that challenge the existing paradigms of science. This could be the detection of a previously unknown celestial body, millions of light years away, or the observation of a particle behaving in ways that defy the established laws of physics. These moments of discovery are the bedrock of our quest for knowledge, as they push the boundaries of what we know and open the door to new realms of inquiry. Yet, discovery alone is not enough to propel us forward. It is only the first step in a much larger process. Understanding is the second dimension, and it is here that the true work of exploration begins. Once we make a discovery, we must work to make sense of it, integrating new information into the existing body of knowledge. Understanding requires not just the ability to interpret data, but also the capacity to synthesize and contextualize it within a coherent framework. For example, when astronomers observe an anomalous cosmic event, perhaps a supernova or the unusual behavior of a black hole, they do not simply catalog the data. They work tirelessly to understand its implications, to decipher what it tells us about the laws that govern the universe. Without this process of understanding, discovery can remain an isolated data point, devoid of meaning or context. It is this second dimension that brings discovery to life, transforming it from a mere fact into a story that contributes to our ever-expanding narrative of the cosmos. The third dimension, inspiration, is perhaps the most profound. It extends far beyond the confines of the scientific community, spilling over into the realms of art, culture, and philosophy. The unexplained phenomena of the cosmos, the vastness of space, the mystery of dark matter, the possibility of life beyond Earth, captivate our imagination, prompting us to ask deeper existential questions. What is our place in this infinite universe? Are we truly alone, or is there life out there waiting to be discovered? These questions evoke awe and wonder, sparking creativity and fueling the desire to explore further. The cosmos, in this sense, becomes a wellspring of inspiration, a source of stories, ideas, and innovations that drive humanity to push the boundaries of knowledge, technology, and thought. The dimensions of discovery, understanding, and inspiration are intricately connected, each one building upon and enhancing the others. A significant discovery may lead to a breakthrough in understanding, which, in turn, can inspire new generations of scientists, explorers, and thinkers to pursue their own questions. This dynamic interplay ensures that our quest for knowledge is not a linear process, but a cyclical one, each phase of discovery feeding into the next. To define success in the exploration of the unknown, we must embrace all three dimensions, recognizing that they are part of a larger quest for meaning in a universe that remains, for the most part, an enigma. As we venture further into the unexplained anomalies of the cosmos, we are invited to reconsider our understanding of reality itself. Phenomena such as dark matter, black holes, and the cosmic microwave background radiation challenge our most fundamental assumptions about the nature of the universe. These enigmatic elements not only stretch the limits of our scientific models, but also remind us that the universe is teeming with wonders yet to be uncovered. Each unexplained anomaly serves as a doorway, leading us to new insights, new questions, and deeper reflections on the very fabric of existence. The mystery surrounding these phenomena sparks curiosity, urging us to ask questions about the nature of time and space, the possibility of parallel universes, or the implications of discovering extraterrestrial life. It is essential to remember that science is an ever-evolving field, driven by constant inquiry and adaptation. This perspective encourages us to embrace uncertainty, to see the unknown not as a barrier, but as a stepping stone toward greater understanding. By acknowledging that there is always more to learn, we invite audiences to engage with the mysteries of the cosmos, not as passive observers, but as active participants in the pursuit of knowledge. The hope is that, after journeying through these cosmic enigmas, individuals will feel inspired to engage with science in ways that extend beyond the classroom or the textbook. Perhaps they will seek out books, documentaries, or discussions that delve deeper into these topics. They might explore how diverse fields, such as physics, astronomy, and philosophy, offer unique perspectives on the universe, each shedding light on different aspects of the cosmos. The journey into the unknown encourages a broader intellectual engagement, inviting individuals to see the interconnectedness of knowledge and to appreciate the value of different ways of thinking. Ultimately, the exploration of unexplained phenomena instills a sense of awe, a reminder that the universe does not simply provide answers, it presents an endless series of questions. This journey emphasizes that knowledge is not only about what we know, but also about what remains to be discovered. By engaging with these mysteries, we ignite a passion for lifelong learning and curiosity as individuals reflect on humanity's place in a vast and unfathomable universe. Through the lens of documentary storytelling, we can explore these themes in a way that captivates and inspires. By presenting the groundbreaking discoveries of astronomers and scientists, the documentary brings the mysteries of space to life, fostering a sense of collective curiosity that transcends the boundaries of academia. It motivates viewers to seek out answers, to ask questions, and to participate in the ongoing dialogue within the scientific community. As topics such as the search for extraterrestrial life or the study of dark matter are introduced, the audience is invited to join in the quest for knowledge. This shared exploration underscores the importance of continued investment in science education and exploration, inspiring future generations of scientists, explorers, and enthusiasts. Moreover, the emotional narratives embedded within the core themes of the documentary strike a deep chord with audiences, creating a personal connection that extends beyond mere scientific facts. It is the human stories, the perseverance, struggles, and triumphs behind each groundbreaking discovery that resonate most strongly. These are not just stories about rockets launching or telescopes peering into the vastness of space. They are about the individuals, fueled by an unrelenting curiosity, who dedicate their lives to pushing the boundaries of what we know about our universe. In this way, the documentary transforms abstract scientific ideas into compelling, relatable human experiences. Audiences may find themselves moved by the perseverance of those who venture into the unknown, driven not only by intellect, but also by the innate human curiosity to understand our place in the cosmos. These are stories that invite viewers to reflect on their own lives, encouraging them to look at science not as something distant or unrelated, but as an essential force shaping the reality in which they live. It is through this personal connection that the documentary keeps the public intrigued, turning distant, impersonal scientific discoveries into emotionally rich, accessible stories that draw viewers in. As the documentary explores the vastness of space, it ultimately underscores that the cosmos is not just a subject for academic study. It is an open frontier, one that calls for exploration. By highlighting the current space missions, cutting-edge research, and the boundless potential for future discoveries, the film paints a roadmap for what lies ahead, one that promises endless opportunities and questions still waiting to be answered. It is this sense of possibility that leaves a lasting impact, motivating audiences to realize that their own curiosity and engagement can contribute to the ongoing adventure of space exploration. This realization makes the pursuit of knowledge feel like an ongoing collective journey, not just a one-sided academic endeavor. Additionally, the documentary helps bridge the gap between science and society, enriching the conversation by sparking new discussions around the most recent discoveries. It not only presents complex ideas like dark matter, dark energy, and the possibility of other dimensions, but does so in an engaging, thought-provoking way. These concepts, which can seem abstract and overwhelming, are introduced in a manner that challenges long-held beliefs and inspires curiosity. The documentary asks the fundamental question: How much of the universe do we really understand? And more importantly, how much is still left for us to explore? It evokes a sense of wonder, underscoring that the unknown is not a void, but a call to delve deeper. In this context, diversity becomes an integral part of the narrative. The documentary not only showcases the work of scientists from various backgrounds, but it highlights the crucial role of underrepresented groups, particularly women and minorities, in the field of cosmology. These perspectives are more than just an important facet of the story. They are a reflection of how inclusive scientific inquiry fosters richer, more varied viewpoints. By celebrating the contributions of these scientists, the documentary encourages viewers to think about how diversity in thought, culture, and experience can push the boundaries of scientific discovery. This representation inspires people from all walks of life to consider their own potential role in the scientific community, fostering a more inclusive and dynamic conversation about the future of space exploration. The documentary doesn't just stay at the surface level of these grand ideas. It takes audiences behind the scenes, exploring the very process of scientific discovery. It shows how theories are formulated, tested, and sometimes disproven, emphasizing that science is not a rigid, final answer, but an evolving discipline. This portrayal of science as an ever-changing field invites viewers to reflect on the fluidity of knowledge itself and how new evidence continuously reshapes our understanding of the world. The documentary encourages viewers to recognize that the pursuit of knowledge is never static. It is a journey of constant discovery and reevaluation. Finally, the documentary does more than just explore the cosmos. It also raises existential questions about humanity's place in the universe. These questions, which tie science to philosophy, ethics, and even spirituality, provide a space for viewers to contemplate not only what we know, but also what we value. What does it mean to be human in such a vast, mysterious universe? What responsibilities do we have, both to each other and to the world we inhabit? By prompting such reflections, the documentary creates a bridge between the scientific and the philosophical, encouraging profound conversations about existence, purpose, and the future of humanity. As the film concludes, it doesn't leave audiences with a sense of closure. Instead, it leaves them with a sense of ongoing curiosity, a desire to continue exploring the unknown. The universe, after all, is filled with mysteries that remain unanswered. Concepts like black holes, the nature of dark matter, and the possibilities of extraterrestrial life are only the beginning of what is yet to be discovered. By focusing on these unresolved questions, the documentary inspires viewers to keep questioning, keep learning, and keep seeking. To foster this curiosity, the documentary encourages viewers to engage with the subject beyond the screen. It offers pathways for further exploration, whether through reading popular science books, listening to podcasts, or attending online seminars. These resources present complex scientific ideas in accessible, engaging ways, making the unknown feel within reach. Platforms like these also provide a space for dialogue, where enthusiasts can connect with experts and other curious minds. This interaction enriches the learning experience, creating a community of people who are all part of the same quest for knowledge. In this way, the documentary doesn't just entertain, it inspires, educates, and empowers its audience to become part of a broader conversation about the future of space exploration. Moreover, documentaries have the remarkable ability to inspire viewers to engage in citizen science projects, initiatives that empower individuals to actively contribute to real scientific research from the comfort of their own homes. These citizen-led projects, like searching for exoplanets or classifying distant galaxies, invite people to become participants in the exhilarating journey of discovery. By making science accessible, they allow ordinary individuals to feel personally connected to the vast cosmos. This active involvement transforms the abstract nature of scientific research into something tangible, sparking curiosity and enthusiasm. Integrating participatory elements directly into documentaries, such as interactive features or prompts for viewers to reflect upon, can serve as powerful tools of inspiration. Ending segments with compelling questions or thought-provoking challenges encourages audiences to explore further, to seek out answers, and to delve into the mysteries that lie just beyond the night sky. These documentaries become more than just passive viewing experiences. They are catalysts that encourage viewers to become explorers of the unknown themselves, deepening their engagement with the world of science. The potential of documentaries to bridge the divide between complex scientific concepts and the broader public is immense. As these films explore phenomena that are still shrouded in mystery, like the nature of black holes, dark matter, or the origins of life itself, a new breed of documentary is emerging. One that not only educates but also engages viewers on a deeply emotional and intellectual level. These films turn intricate scientific ideas into compelling visual narratives, making them accessible and relatable. By focusing on rich storytelling, they not only explain the science, but also spotlight the human element behind the research. Viewers connect not just with the discoveries, but with the people whose passion and perseverance drive the exploration of these grand questions. Through advanced visual effects, filmmakers can create immersive simulations that bring abstract scientific concepts to life. Whether it's soaring through the cosmos, witnessing particle collisions at a subatomic level, or venturing into the darkest depths of the ocean, these visual tools allow viewers to experience science in a way that traditional textbooks simply cannot. The result is a dynamic visual feast that ignites curiosity, stirs questions, and encourages conversations that extend far beyond the documentary itself. When audiences witness the awe-inspiring beauty of the universe alongside the complexities of scientific phenomena, they are more likely to engage with the material and seek a deeper understanding. Looking ahead, one of the most exciting directions for future documentaries is the inclusion of diverse voices in the field of science. By highlighting research from underrepresented communities, showcasing international collaborations, and incorporating indigenous knowledge, documentaries can offer a richer, more inclusive perspective on scientific discovery. This expanded worldview not only deepens the narrative, but also fosters a sense of shared ownership in the quest for understanding. When viewers see that science is not the exclusive domain of a select few, but a global endeavor shaped by many, many voices, it encourages a more inclusive and interconnected relationship with the knowledge being shared. As technology continues to evolve, so too will the methods of storytelling. Virtual reality, VR, is already beginning to offer immersive experiences that allow viewers to step directly into the environments being studied. Imagine being able to stand on the surface of Mars, explore the inner workings of a black hole, or witness the moment of a supernova explosion. These technologies have the potential to make scientific exploration feel immediate and visceral, making the viewer an active participant in the experience. With VR and other immersive tools, the boundaries of what is possible in documentary filmmaking are expanding, offering new ways to experience the world of science. In the future, documentaries will increasingly serve as not only a source of education, but also as a means of fostering a deeper appreciation for the mysteries that science seeks to unravel. They will allow viewers to see science not as a distant, abstract field, but as a thrilling and ever-evolving adventure that is both accessible and deeply personal. By making the extraordinary dimensions of science relatable and engaging, documentaries will continue to resonate with audiences worldwide, shaping how we understand the world around us and inspiring the next generation of scientific minds. The future of storytelling lies in its ability to transform complex phenomena into accessible, emotionally resonant experiences, ensuring that the wonder and mystery of science remain a source of fascination for years to come.